There is a photograph that stops researchers cold when they first see it, not because it is dramatic or violent or even particularly striking at first glance. It is just a face. A man in his 60s, maybe 70s, standing somewhere in the Outer Hebrides with the wind pulling at the collar of his jacket and the grey Atlantic sky pressing down behind him. He is not posing. He is just standing there, looking at whoever is holding the camera with calm, dark eyes set beneath a heavy brow, and his skin is this deep olive tone that catches the light in a way that feels wrong for where he is standing, wrong for the latitude, wrong for everything you think you know about people who live this far north on the edge of a cold and stormy sea. Researchers who study population genetics and ancient migration patterns have seen this face, or faces like it, again and again, not just in the Hebrides, in the Orkneys, in Shetland, in the westernmost corners of Ireland, in the Isle of Man, in small fishing villages on the Cornish coast that have barely changed their names since before the Romans arrived. They call it by different names depending on which part of the literature you read: the dark Celtic type, the Atlantic phenotype, the pre-Indo-European relic population. But what they are all pointing at is the same quiet mystery. There are people living on the islands and Atlantic fringe of Britain and Ireland who look fundamentally different from what most of us picture when we imagine European ancestry. And the reason why goes so much deeper than anyone taught you in school. Deeper than the Vikings, deeper than the Celts, deeper than anything that happened in the last 3,000 years. It goes back to a time when Britain was not Britain at all, when the islands had different names or no names that survived, when the sea levels were different and the coastlines were different, and the people who first walked these edges of the world carried genetics that had never existed anywhere else in quite that combination. If you are watching this to fall asleep, that is exactly why I make these videos. Maybe subscribe and let me know where you are right now and what time it is. I always check the comments and it still surprises me every time. Someone in the Orkneys watching at 2 in the morning, someone in New Zealand who has never seen Britain but feels something pull when they hear about its oldest peoples. Someone in a city apartment surrounded by noise who needs the slow weight of deep time to carry them somewhere quieter than the room they are sitting in. This is that kind of video. There is no rush here. The story of why island people look the way they do is not a simple story. It is not the story you would get from a single documentary or a genealogy website, or even most university courses in British history. It is the kind of story that requires you to sit with uncertainty for a while, to hold competing explanations at once, to accept that the bones and the DNA and the stone monuments and the old place names and the ancient texts are all pointing in the same direction, but none of them alone is enough to prove what they are all suggesting together. What they suggest is this: the people on Britain's Atlantic islands are not simply the remnants of Celtic migrations that happened 3,000 years ago. They are not just Norsemen who stayed. They are not even primarily the descendants of the farming populations that arrived from the Near East 10,000 years ago and spread across most of Europe. They are something older and stranger. They are the biological echo of a population that was already ancient when the megalith builders began stacking stones into circles on the Orkney hilltops. They carry, in measurable and documented ways, genetic signatures that connect them not just to the rest of Europe, but to populations thousands of miles away. And the patterns of that connection are not random. They follow the coastlines. They follow the sea routes. They follow the same paths that humans have been traveling since the ice retreated and the ocean filled back in, and the Atlantic world took the shape it has today. To understand this properly, you have to go back, not a few centuries, not even a few millennia. You have to go back to the ice. 14,000 years ago, give or take a few centuries on either side, Britain looked nothing like it looks today. The island did not exist yet as an island. The North Sea was a landscape, not a sea. You could walk from what is now Norfolk to what is now the Netherlands across a broad, cold plain that researchers have named Doggerland, after the Doggerbank, where North Sea fishing trawlers occasionally dredge up the bones and tools and teeth of the people who once lived there. This was not a marginal territory. This was a rich, productive landscape of rivers and wetlands and seasonal hunting grounds, and it was populated. People lived there, hunted there, built fires there, buried their dead there, and then watched as the ice to the north began to release its grip on the water. It had locked away for tens of thousands of years, and the sea began to rise, slowly at first, then faster. The rivers widened into estuaries. The high ground became islands, the islands became smaller. And somewhere around 8,000 years ago, the last land bridge connecting Britain to the European continent went underwater, and Britain became an island, and the people who were standing on what would become the British side of that divide were left behind, cut off from the populations expanding across continental Europe, left to develop in relative isolation on the edges of the Atlantic. Those people were not the Celts. They were not the ancestors of what we now call Celtic civilization. They were something that predates the Celtic world by thousands of years, and they left their fingerprints everywhere on the landscape of Britain if you know how to read them. They left them in the stone monuments that still stand on the hilltops and clifftops of Orkney and Shetland and the Outer Hebrides. They left them in the place names that linguists cannot connect to any known language family. They left them in the genetics of the people who still live in these places today, the people who carry haplogroups and genetic markers that are older than the farming revolution, older than the Bronze Age migrations, older than almost anything else in the European genetic record, and they left them in those faces. The dark eyes, the heavier brow ridges, the deeper olive skin tones that show up again and again in the populations that stayed closest to the sea, that were most isolated from the waves of migration that reshaped the rest of Europe over the last 5,000 years. Western hunter-gatherers is the name population geneticists use for the people who inhabited Western Europe before the arrival of farming populations from Anatolia. The abbreviation is WHG, and if you spend any time reading ancient DNA literature, you will see it everywhere. These people were the indigenous inhabitants of the Atlantic fringe. They had dark or medium-dark skin by modern standards, blue or dark eyes in varying proportions depending on which population you are sampling, and genetics that are distinct enough from both modern Europeans and from ancient Near Eastern populations that researchers can identify their signature clearly in ancient DNA samples from archaeological sites across Britain, Ireland, Scandinavia, and Western continental Europe. What makes the Atlantic Islanders interesting, what makes them worthy of an entire investigation like this one, is that they carry measurably more of this WHG ancestry than almost any other surviving population in Europe. The farming revolution that swept out of Anatolia around 9 or 10,000 years ago gradually replaced or absorbed the WHG populations across most of Europe. In some regions, the replacement was nearly total. In others, some mixing occurred, and WHG ancestry persists at low percentages in the modern population. But in certain specific places, places that were geographically isolated, places that the farming wave reached late or weakly, places where the sea provided both protection and a different kind of economy, the WHG ancestry persisted at much higher rates. Orkney, Shetland, the Outer Hebrides, the western coasts of Ireland, the Isle of Man. These are not randomly scattered locations. They are the places that geography made hardest to reach overland, the places where the old populations could hold on longest, and the places where the descendants of those populations still live today. The numbers are striking when you look at them directly. Modern population studies using ancient DNA comparisons have found that some island and Atlantic fringe populations in Britain and Ireland carry WHG ancestry at levels 2 to 3 times higher than populations in Central and Eastern England. This is not a small difference. This is not statistical noise. This is a genuine signal of genetic continuity going back to before the Neolithic, before anyone was farming in Britain, before the monuments were built, all the way to the hunter-gatherers who were standing on the Atlantic edge of Europe, watching the ice retreat and the sea rise and the world reshape itself around them. They did not disappear. They persisted. And in the faces of people standing in Orkney fishing villages with the wind off the Atlantic catching their dark hair and their sea-grey eyes, you can still see them, still present, still looking back at you across 12,000 years. But WHG ancestry is only one layer of this story, and in some ways it is not even the most interesting layer, because the islands of Britain are not just repositories of ancient European hunter-gatherer genetics. They are also the place where a second genetic stream, one that researchers are only beginning to understand properly, survived in unusually high concentration. And this second stream is stranger. It connects the Atlantic Islanders not just to ancient European populations, but to populations in places that seem at first glance completely disconnected. North Africa, the Caucasus, And most startling of all, the indigenous peoples of the Americas. This is where the story gets complicated in ways that most popular histories of Britain and Ireland simply skip over entirely. The Atlantic megalithic tradition is the name researchers use for the culture, or family of related cultures, that built the great stone monuments along the western edges of Europe starting around 6,000 years ago. The passage tombs of Ireland, the standing stones of Brittany, the henges and stone circles of Orkney and the Outer Hebrides, the megalithic tombs of Iberia. These monuments share structural similarities that are too consistent to be coincidental. The same basic design principles appear from Portugal to the Orkneys, separated by thousands of kilometers of coastline, but connected by the sea routes that the people who built them clearly knew intimately. Whoever these people were, they were sailors. They were coastal people. They moved along the Atlantic facade of Europe in boats that we cannot fully reconstruct, because boats made of wood and hide do not survive 6,000 years, and they carried with them not just the stones but the knowledge of how to align them, how to build them, how to make the midwinter sunrise fall exactly through the entrance passage of a tomb at a latitude that required precise astronomical calculation to get right. The genetic signature of these megalith builders has been partially recovered from ancient DNA samples taken from burial sites in Ireland, Britain, Iberia, and Brittany. What researchers found when they analyzed those samples was that the megalith builders were primarily descended from early Neolithic farmers who had arrived on the Atlantic coasts from Anatolia via the Mediterranean, but who had, during their long migration along the coast of Iberia and eventually into the Atlantic islands, mixed significantly with the WHG populations they encountered along the way. The result was a hybrid population, neither purely Near Eastern farmer nor purely European hunter-gatherer, but something that combined elements of both in proportions that varied by location and that became genetically distinctive over the generations of relative isolation on the Atlantic coast. This population, the Atlantic Neolithic, is the second major genetic stream that flows through the island populations of Britain and Ireland, and it too is present at higher concentrations in the same places that show elevated WHG ancestry: the Western Islands, the coastal fringes, the places the sea protected from subsequent waves of migration. This means that when you are looking at someone from the Outer Hebrides or the Orkneys or the Western Irish coast who has that distinctive combination of dark or olive skin with very light eyes, what you may be seeing is the phenotypic expression of a genetic ancestry that blends two of the oldest population streams in Western Europe: the hunter-gatherers who were here before anyone farmed this land, and the coastal Neolithic farmers who built the stone circles and the passage tombs and the great houses at Skara Brae on Orkney before the pyramids of Egypt were old enough to have their corners eroded by the desert wind. These are not recent ancestries. These are not Viking era or Celtic era or even Bronze Age contributions. These are the deep strata of the population, the ones that lie underneath everything else that happened later, and they are still visible because the islands preserved them in ways that the mainland simply could not. Skara Brae is worth pausing on for a moment because most people know the name but do not quite register what it means for this story. The settlement at Skara Brae on the Orkney mainland is one of the best preserved Neolithic villages in the world. It was buried under sand for most of the last 4,000 years, which is why it survived, and when a storm uncovered it in 1850, the buildings it revealed were astonishing. Stone furniture, stone shelves, stone beds, stone dresser-like structures that stood in the same position in each house, facing the entrance, suggesting a shared cultural practice of displaying objects that mattered, whether those were bones or beads or ceremonial items or simply the things a household considered important enough to put where visitors would see them first. The settlement dates to roughly 3,100 BCE, making it contemporary with the late phase of construction at Stonehenge, and roughly the same age as the great megalithic tombs at Newgrange in Ireland. The people who lived at Skara Brae were farmers, but they were also fishermen and hunters, and they were connected to the wider Atlantic megalithic world by the design principles visible in their buildings and by the genetic evidence that links them to the same coastal Neolithic tradition that built monuments from Portugal to Scandinavia. They were, in a word, islanders, isolated enough to develop distinctive characteristics, connected enough to maintain cultural and probably genetic links with the wider Atlantic world. And their descendants are still there, still living on Orkney, still carrying in measurably elevated proportions the genetic signatures that researchers have now recovered from the bones of the people who built those stone beds and those stone shelves 5,000 years ago. The continuity is not perfect. No continuity across 5,000 years could be perfect. There were later arrivals. There were Bronze Age populations who brought new genetics and new technologies. There were the Picts, whose origins remain genuinely mysterious even to specialists who have spent careers trying to understand them. There were Norse settlers who came in the 9th and 10th centuries CE and left genetic and linguistic signatures so strong that some of the place names on Orkney today are still Norse in origin, still carrying the sounds of Old Norse, spoken by people who arrived in longships 1,000 years ago and stayed. But underneath all of those later layers, the ancient signal persists. It is detectable, it is measurable, and in the physical appearance of some of the people who live on these islands today, it is visible in ways that have puzzled outside observers for centuries, long before anyone had the tools to explain what they were actually seeing. Before we can go any further into the genetics, we need to talk about haplogroups, because the haplogroup distribution among Atlantic island populations in Britain is one of the most striking features of their genetic profile, and one that most general histories of British identity simply never mention. Haplogroups are inherited genetic markers, passed down through either the direct male line on the Y chromosome or the direct female line in mitochondrial DNA, and they allow researchers to trace ancestry back thousands of years with remarkable precision. Different haplogroups have different geographic origins and different migration histories, and when you look at the haplogroup distribution among populations in Orkney, Shetland, the Outer Hebrides, and the western Irish coast, certain patterns emerge that are genuinely difficult to explain using the simple narrative of Celtic and Norse ancestry that most people have been taught. The haplogroup I1, strongly associated with Norse and Scandinavian ancestry, is present and elevated on Shetland and Orkney in ways that reflect the documented Norse settlement. This is not surprising. What is surprising is the distribution of older haplogroups, particularly I2 in its various subclades and certain configurations of haplogroup R1b, that appear at elevated frequencies in Atlantic island populations, and that predate the Norse settlements by thousands of years. Haplogroup I, in general, is one of the oldest haplogroups in Europe, associated with European hunter-gatherer populations that preceded both the Neolithic farming expansion and the later Bronze Age steppe migrations. Finding elevated frequencies of ancient I subclades alongside the Norse-associated I1 frequencies suggests that the Norse settlers were not arriving into an empty genetic landscape. They were arriving into a landscape already populated by people carrying very old genetics, and the genetic profile of modern Orkney and Shetland reflects both of those populations simultaneously, the ancient and the recent layered on top of each other in proportions that vary by island and by community. But it is the mitochondrial haplogroup picture that is most striking when you look at the Atlantic island populations as a whole. Mitochondrial DNA, passed only through the female line, tells you about the maternal ancestry of a population. And in the Atlantic island populations of Britain and Ireland, certain mitochondrial haplogroups appear at frequencies that are not just elevated compared to the rest of Europe, but appear at frequencies that are globally unusual. Haplogroup H, the most common mitochondrial haplogroup in Western Europe generally, is present and dominant. But it is the distribution within the subclades of H and the frequencies of rarer haplogroups alongside it that catches the eye of researchers who know what they are looking at. Haplogroup X, in particular, appears at elevated frequencies in Atlantic island populations, and haplogroup X is one of the most discussed and most controversial markers in all of ancient DNA research, for reasons that go far beyond the shores of Britain. Haplogroup X is rare globally. It is present in roughly 3 to 4% of European populations on average, elevated in certain specific European populations, including some Atlantic fringe groups, and then, in a pattern that researchers noticed decades ago and have never been able to fully explain, it appears in the indigenous populations of North America. In certain Native American populations, particularly in groups from the Great Lakes region of Canada and the United States, haplogroup X appears at frequencies of 15 to 25%. Not in Asia, not in Siberia, where most Native American ancestors are assumed to have originated via the Bering land bridge route. In North America directly, concentrated in populations in the northeastern part of the continent, at frequencies far higher than anywhere along the standard migration routes. This is one of the most debated findings in all of population genetics, and we will come back to it in detail later in this investigation. But it is relevant here, at the beginning, because haplogroup X is one of the markers that appears at elevated frequencies in the same Atlantic island and fringe populations of Britain and Ireland that show elevated WHG ancestry and elevated Atlantic Neolithic ancestry. The connection between Scottish and Irish island genetics and certain Native American genetic profiles is not a coincidence. It is not a recent contamination or a measurement error. It is a real signal in the data, and it points towards something that no one has yet been able to explain completely satisfactorily, something about the deep history of the Atlantic world and the people who moved across it and through it and along its edges in the thousands of years before any written record existed to document what they were doing. To get from haplogroup X in the Outer Hebrides to haplogroup X in the Great Lakes Basin, you need a theory of how it got there, and there are really only a small number of theories that hold up to scrutiny. The standard model of Native American ancestry posits that all the founding populations of the Americas arrived via Beringia, the land bridge between Siberia and Alaska that was exposed during the last glacial maximum when sea levels dropped far enough to create a connection between the Asian and American continents. Under this model, haplogroups A, B, C, and D, which are the dominant mitochondrial haplogroups in Native American populations across the continent, were brought by those Beringian migrants and spread as they moved south and east across the Americas over thousands of years. Haplogroup X does not fit this model neatly. It is not present in the Siberian populations that are the presumed source of the Beringian migrants. It is not distributed across Native American populations in the way you would expect if it arrived through the same route as the other founding haplogroups. It is concentrated in the northeast, in populations that would have been among the last to be reached by any southward expansion from Beringia, and it is found in Europe, specifically in the Atlantic fringe populations of Europe at elevated frequencies. There are several possible explanations. One is that haplogroup X was indeed brought via Beringia, but was carried by a small founding group that happened to land in a part of the continent where it subsequently expanded while dying out in the Siberian and Central Asian populations that would have been its source. This is possible but requires a number of coincidences stacked on top of each other that some researchers find uncomfortable. Another possibility, one that is not accepted by mainstream archaeology, but has been proposed seriously by some geneticists, is that haplogroup X entered the Americas via a separate route, a transatlantic route, before or during the last glacial maximum, carried by populations moving along the edge of the North Atlantic ice sheet from Europe toward North America. This is the Solutrean hypothesis in its genetic version, and it remains genuinely controversial in ways we will explore carefully later, because it is both a fascinating possibility and one that has been seriously misused by people with agendas that have nothing to do with science. A third possibility is that haplogroup X arrived in North America separately from the main Beringian migration, but via a different Asian source population that carried it at low frequencies, a source population that has since disappeared from the genetic record without leaving descendants in the places you would expect to find them. Each of these explanations has problems. None of them is entirely satisfying. And that is exactly why the distribution of haplogroup X, from the Scottish Islands to the Great Lakes Basin, remains one of the genuinely unresolved puzzles in the genetic history of humanity. For now, what matters is that the Atlantic island populations of Britain and Ireland are carrying genetic signals that connect them not just to the rest of Europe, but to deeper and stranger networks of human movement and ancestry. And those signals are visible. They express themselves in the physical appearance of people living on these islands today, in a set of phenotypic traits that show up consistently enough in these populations that outside observers have been noting and puzzling over them for centuries. The dark skin tones at a latitude that should theoretically favor lighter pigmentation, the heavier brow structures, and more pronounced facial architecture. The specific combination of features that makes someone from the Outer Hebrides look, to the trained eye, genuinely different from someone whose ancestry comes primarily from the English Midlands or the lowland areas of Scotland that had a different migration history and consequently a different genetic composition. This is not about racial categories in any modern sense. It is not about hierarchy or superiority or any of the things that 19th century pseudoscience tried to graft onto observations about physical variation within European populations. It is about the genuine biological consequences of population history, about the fact that groups of people who were isolated on islands off the Atlantic coast of Europe for long periods, who received later waves of migration differently or later or in smaller proportions than mainland populations, and who maintained greater continuity with the earliest inhabitants of their islands, will look different from populations with a different history. The physical differences are real. They are visible. They have been documented in anthropological literature for over 100 years. And what modern ancient DNA research has finally given us is the ability to understand why those differences exist at the level of actual genetics rather than speculation. The skin pigmentation question is particularly interesting because it was one of the things that 19th century observers consistently noted and consistently misunderstood. The presence of darker skin tones in populations living at very high latitudes seemed paradoxical to early physical anthropologists, who assumed, following the logic of selection pressure, that all populations at high latitude should have evolved toward lighter skin to maximize vitamin D synthesis in low-light conditions. And this logic is sound as far as it goes. Natural selection does favor lighter skin at high latitudes, and this is why most populations that have lived at high latitudes for many thousands of years are light-skinned. But the key phrase is many thousands of years. The WHG populations that contributed to the Atlantic island gene pool were at high latitudes, yes, but they had not been there long enough, in evolutionary terms, for selection to have fully lightened their pigmentation before the later populations arrived and the genetic mixing occurred. The WHG populations themselves showed evidence of dark or medium-dark skin, dark or mixed eye pigmentation, and other traits associated with populations that had recently arrived in Europe from warmer latitudes to the south. And in the Atlantic island populations, where WHG ancestry has remained elevated compared to mainland populations that experienced more thorough replacement by lighter-skinned incoming groups, some of those original pigmentation characteristics have persisted. This is a simplified version of what is actually a multi-gene, complex trait story involving dozens of genes that influence pigmentation, each contributing small effects that interact with each other and with environmental pressures in ways that population geneticists are still working to fully characterize. But the basic principle is sound. The Atlantic Islanders carry more of the ancient European hunter-gatherer ancestry than most other European populations. The ancient European hunter-gatherers had darker pigmentation than later incoming populations. Therefore, the Atlantic Islanders, in measurable proportions, show phenotypic traits that reflect that deeper, older ancestry. It is not a mystery in the sense of being inexplicable. It is a mystery in the sense of being a story that has been buried under layers of simpler narratives about Celtic and Norse ancestry, and that requires you to look much further back in time than most popular histories of Britain ever think to look. Now we need to talk about the Picts, because no investigation into the deep genetics of the Scottish Islands can avoid them, and because the Picts themselves are one of the genuinely mysterious populations in European history, a people who existed, who built and carved and fought and left a record of themselves in the most enigmatic artistic tradition in the British Isles, and about whom we still know so little that entire careers can be built on trying to understand them and still end without definitive answers to the most basic questions. Who were they? Where did they come from? What language did they speak? And why do the symbols they carved into standing stones across northern and eastern Scotland and the islands off its coast share features with symbolic systems from cultures that should have had no contact with Iron Age Pictland? The Picts are first mentioned by Roman sources in the late 3rd century CE, though the people referred to by that name had obviously been living in the north of Britain long before Roman writers thought to name them. The name itself, Picti, is Latin, and probably refers to the practice of body painting or tattooing that the Romans found notable about these northern peoples, though even this is debated. What we know from the historical record is that the Picts inhabited the area north of the Forth Clyde Line, the part of Britain that the Romans never managed to conquer or hold, and that they were formidable enough militarily to have required the construction of Hadrian's Wall, and later the Antonine Wall to define and defend the northern limits of Roman Britain. They were not a single, unified ethnic group in any modern sense. They were a confederation of peoples sharing enough cultural characteristics, including their distinctive carved symbol stones, to be recognizable to outsiders as a coherent cultural unit. And then, in the 9th and 10th centuries CE, they seemed to disappear from the historical record, absorbed into the emerging kingdom of Alba that would eventually become Scotland, their language ceasing to be spoken, their distinct political identity dissolving into the new Gaelic-speaking kingdom. What remains is the art. And the art is extraordinary in ways that make it one of the most discussed and most debated bodies of material in all of British archaeology. The Pictish symbol stones, several hundred of which survive across the former Pictish territories, including the northern and eastern islands, are covered in a repertoire of symbols that are immediately recognizable as Pictish and that do not appear anywhere else in the world in the same combination. There are zoomorphic symbols, animals rendered in a style of extraordinary fluidity and naturalism, creatures twisting around themselves or frozen in positions that somehow convey both stasis and movement. There are abstract geometric symbols, double discs and Z-rods and V-rods and mirror and comb symbols, whose meanings have been debated for 2 centuries without reaching anything approaching consensus. And there are what researchers call the tuning fork symbol and the swimming elephant, and several others whose names in the scholarly literature are honest admissions that no one knows what they are actually representing. The Pictish symbols are clearly a communication system. They appear in consistent combinations on stones across a wide geographic area, which means they carried shared meaning that was legible to people across that territory. Some researchers have argued that they represent a proto-writing system, a way of encoding information in symbols that had not yet evolved into a full phonetic script. Others argue they are clan or family markers, aristocratic emblems identifying the lineages of people buried nearby or commemorated in the carvings. Others still suggest they have primarily religious or cosmological significance, representing elements of a symbolic vocabulary connected to Pictish spiritual practice. None of these interpretations is wrong exactly, but none of them is fully satisfying either, and the honest answer is that without a Pictish Rosetta Stone, without text in a known language that also contain Pictish symbols in translation, we cannot be certain what the symbols meant to the people who carved them. What we can say is that Pictish art does not look like Romano-British art. It does not look like early medieval Irish art, though there are points of contact and influence in both directions as these cultures interacted, and in certain specific respects, it does not look like anything else in northwestern Europe in its period at all. The zoomorphic style, particularly, has been compared by some researchers to art traditions from places so far removed from Pictland that the comparisons initially seem absurd. There are points of stylistic similarity between Pictish animal art and certain traditions from the Caucasus. There are features of the abstract symbol repertoire that some researchers have compared, very tentatively, to traditions from the ancient Near East. These comparisons have mostly been dismissed by mainstream archaeologists as the kind of superficial pattern matching that produces false connections, because humans are inclined to see similarities and underestimate how often independent artistic traditions arrive at similar solutions to similar representational problems. But they have not been dismissed entirely, and they feed into the broader question of what the pre-Celtic, pre-Roman substrate population of the Scottish Islands and Highlands actually was and where it came from. The Pictish language is its own layer of mystery. We have a small number of texts in what appears to be Pictish, primarily on Ogham-inscribed stones, and they are largely undeciphered. The Ogham script, developed in Ireland to write Old Irish, was borrowed by Pictish speakers, but the texts written in that borrowed script are not Old Irish. They are not Brythonic Celtic either, the language family that includes ancient Brittonic and its descendants Welsh and Cornish. And they are not anything else in the known linguistic record of Britain or Ireland. Some researchers have argued that Pictish represents a survival of a pre-Indo-European language, a language from a time before the Indo-European language family spread across most of Europe during the Bronze Age migrations. If this is correct, It would mean that the Picts preserved not just ancient genetics but ancient language, that they were in linguistic terms as well as biological terms a relic population, a survival of a world that existed before the languages most people speak today, spread across Europe and replaced what was there before. This is controversial because pre-Indo-European language survival is difficult to prove with the limited Pictish textual record available. But it is notable that the one language in Western Europe that is unambiguously pre-Indo-European, the Basque language of the Pyrenean region, is also associated with a population that shows elevated ancient hunter-gatherer ancestry and that carries haplogroups similar to those found in elevated proportions in the Atlantic island populations of Britain and Ireland. The Basques are the population with the highest known frequency of Rh-negative blood type in the world, a genetic trait whose distribution across Europe follows the Atlantic fringe in ways that parallel the other genetic markers we have been discussing. The Basques speak a language that has no known relatives anywhere in the world and that preserves features that linguists believe reflect the grammar and vocabulary of the people who inhabited Western Europe before the Indo-European expansion. And the Basques look, to the trained eye, phenotypically distinct from the surrounding Spanish and French populations, carrying a higher frequency of the dark eye, heavier featured traits that also characterize the Atlantic island populations of Britain. The Basques and the Scottish Islanders are not the same people. They have not had recent direct contact in any documented historical sense, but they share ancestry, deep ancestry, the kind that shows up in haplogroup distributions and WHG percentages and the physical characteristics that those ancestries express. They are cousins in the oldest possible sense of that word, the children of the same population that once stretched along the Atlantic facade of Europe before the farming revolution arrived from the east, and the Bronze Age steppe migrations arrived from the northeast, and the world that had existed for thousands of years was reorganized into the Europe we recognize today. The Atlantic fringe populations, from Iberia to the Orkneys to the Outer Hebrides, preserved more of that old world than anyone else, and the Basques and the Scottish Islanders, standing at opposite ends of the Atlantic facade, are its most visible survivors. To understand what happened to the people of the Atlantic fringe, you need to understand what the Bronze Age migrations actually were, because this is one of the most consequential genetic events in all of European history, and one that most people have never heard described in terms of what the ancient DNA evidence has revealed about its scale and speed. Around 4,500 years ago, a population explosion began on the Pontic-Caspian steppe, the vast grassland region that stretches from the northern Black Sea coast eastward into Central Asia. The people who initiated this explosion were pastoralists, herders who had developed a way of life based on mobile livestock management, supported by wheeled vehicles, riding horses, and a subsistence economy that allowed them to range across the steppe in ways that settled farmers could not. They were descended from a mixture of ancient steppe hunter-gatherers and Caucasian hunter-gatherers, and they carried a distinctive genetic profile that researchers call the Yamnaya ancestry, after the Yamnaya archaeological culture, that is the first well-documented expression of their cultural and demographic expansion. And they carried, in extremely high frequency, the Y chromosome haplogroup R1b in its Western European subclade variants. Between roughly 2,800 and 1,800 BCE, Yamnaya-derived populations spread across Europe with a speed and thoroughness that ancient DNA research has only recently been able to document fully. In Britain and Ireland, the impact was particularly dramatic. Studies comparing ancient DNA from the late Neolithic period with DNA from the subsequent early Bronze Age have found evidence for what some researchers describe as near-total replacement of the pre-existing population in large parts of Britain within the span of a few centuries. The people who had been building Stonehenge and Avebury and the great monuments of the Wessex tradition in southern Britain were largely replaced, within a timescale that is shocking by any standard, by incoming populations carrying Yamnaya ancestry. The genetic contribution of the Neolithic British population to the subsequent Bronze Age population in many parts of the country dropped from nearly 100% to something in the range of 10% or less. This is population replacement on a massive scale, and it has generated significant debate about what mechanism could have caused it. Warfare is one obvious possibility. Disease is another, and some researchers have noted that the incoming Yamnaya-derived populations may have carried pathogen resistances that the Neolithic British populations, who had been genetically isolated long enough to develop a different immune profile, did not have. A combination of factors is most likely, and the honest truth is that whatever happened, it happened fast enough that the archaeological and genetic record cannot distinguish clearly between its component causes. What matters for this story is that the replacement was not uniform across Britain. It was most thorough in the regions that were most accessible to newcomers arriving from the continent, the lowlands, the river valleys, the agricultural heartlands of southern and eastern England. It was least thorough in the regions that geography protected from rapid influx: the uplands, the western coasts, the islands. In Orkney, in Shetland, in the Outer Hebrides, the genetic continuity from the Neolithic through the Bronze Age is measurably higher than in other parts of Britain. This does not mean the steppe migrations did not reach these places. They did, eventually, and the haplogroup R1b frequencies in modern island populations reflect that. But they reached them later, and perhaps in smaller initial numbers, and the mixing that occurred when they did arrive produced outcomes that preserved more of the ancient genetic baseline than the near-wholesale replacement that occurred in parts of southern England. This is one of the reasons why the islands look genetically different from the mainland, not because nothing happened there, but because what happened there happened differently, on a different timeline, with different outcomes that left the oldest genetic layers intact at higher frequencies. The Neolithic populations of the Scottish Islands were not passive recipients of this demographic transformation. There is evidence, in the archaeological record, of the late Neolithic culture in these areas continuing for generations after it had been replaced or dramatically altered further south. The building tradition at Skara Brae and at related sites on Orkney shows continuity through a period when the Neolithic world was collapsing elsewhere in Britain. The people who were living in those stone-built houses, farming and fishing, and maintaining their connection to the wider Atlantic megalithic world, were still there, still present, still identifiable in the genetic record, while the world to the south was undergoing a transformation that would eventually reach them too. When it did reach them, it found a population that had been stable and isolated long enough to be genuinely distinctive, and the mixing that resulted preserved that distinctiveness in the genetic profile of the modern populations rather than erasing it entirely. This is the deep geological layer of the Scottish island identity, the WHG ancestry below everything, the Atlantic Neolithic ancestry from the megalith-building coastal farmers, the modified and reduced but still real Yamnaya-derived ancestry from the Bronze Age, and then the later layers, the Iron Age populations, the Picts, the Norse, each one adding something to the genetic composition of the modern island population, but none of them completely erasing what came before, because the islands are islands, and islands protect. They make it harder for outside populations to arrive in overwhelming numbers. They create natural barriers that slow the genetic transformations that sweep rapidly across connected landscapes. They are refugia, in the literal biological sense of that term, places where populations that would have been replaced or diluted on the mainland can persist and maintain their distinctiveness for longer. In the genetic literature, this kind of geographic protection is called refugial persistence, and it is a well-documented phenomenon in population genetics. Island populations across the world show elevated retention of ancestral genetic variants compared to related mainland populations because islands receive fewer migrants, and the migrants they do receive are diluted by the existing island population rather than overwhelming it. The Atlantic islands of Britain are a textbook example of this process. Their unusual genetic profile, their elevated ancient hunter-gatherer ancestry, their higher frequencies of the oldest European haplogroups, their distinctive physical appearance, all of this is the biological consequence of being islands on the Atlantic edge of Europe, far enough from the major migration routes to have been partially insulated from the demographic transformations that reshaped the rest of the continent. But there is something else happening here that goes beyond simple refugial persistence, something that points outward from the islands rather than inward, something about the Atlantic itself as a medium of connection rather than just a barrier. Because the islands of Britain's Atlantic fringe were not simply isolated, they were connected, deeply and consistently, to other populations along the Atlantic facade of Europe. The sea routes that linked Orkney to Shetland, Shetland to the Faroe Islands to Iceland, and the western Scottish islands to Ireland and Brittany, and eventually to Iberia, were active long before the Norse arrived in their longships. They were active in the Neolithic, they were active in the Bronze Age. And the evidence for that activity is not just archaeological, it is genetic, and it tells a story about the Atlantic world as a connected space, a zone of maritime interaction and exchange that challenges the picture of isolated island populations waiting passively for outside influences to arrive. The standing stones of Lewis in the Outer Hebrides, at the ancient site known as Callanish, are one of the most striking monuments in all of Britain and one of the least visited compared to its deserved prominence in the history of megalithic construction. The stones at Callanish were erected around 5,000 years ago, making them roughly contemporary with the great monuments of the Boyne Valley in Ireland and with the early phases of construction at Stonehenge. They are arranged in a pattern that is more complex than it first appears. A main stone circle with avenues of stones extending outward in the cardinal directions, and a slightly off-center alignment that researchers have connected to the movements of the moon at its southernmost rising point, an event that occurs only once every 18.6 years, and that would have required sustained observational records across multiple generations to predict and plan around. The people who built Callanish were not primitive in any sense that word is intended to carry. They were astronomers. They were engineers. They were part of a wider Atlantic world that shared knowledge and technique, and possibly personnel across the sea routes that connected the islands of the Hebrides to Ireland and Brittany and the Iberian Atlantic coast. The genetic evidence supports this picture of connected maritime communities. Ancient DNA from megalithic tombs in the Hebrides shows genetic affinities with populations from Ireland and from Brittany that cannot be explained by overland migration paths. These communities were connected by sea, and the connection was close enough, sustained enough, to leave a recognizable genetic signature. The people burying their dead in the passage tombs of the Boyne Valley, and the people erecting the standing stones on Lewis, and the people building the stone-aligned monuments of Brittany were not the same people in a simple ethnic sense, but they were related, they were in contact, and they shared a cultural and genetic heritage that makes them recognizable as members of the same broad Atlantic world, even when sampled from sites separated by thousands of kilometers of coastline. This is the context in which the unusual genetics of the Scottish Islands need to be understood, not as the remnants of isolated populations that happen to avoid contact with the rest of Europe, but as the surviving representatives of a connected Atlantic world, a maritime civilization without cities, a culture without writing, a network of peoples who shared knowledge and genes and cultural practices across the open sea before the sea became a barrier rather than a road. The Atlantic world that the islands represent is older than anything we usually think of when we use the word civilization. It is older than Stonehenge. It is older than the pyramids. It is a world that existed and thrived and left its mark on the landscape of the British Isles and the biology of the people who live there today. And it is a world that has been largely invisible to the written historical tradition because it predates writing, because its monuments have been explained as the primitive achievements of backward people rather than the sophisticated infrastructure of a maritime culture, and because the people who are its most direct biological descendants have been living quietly on their islands, going about their lives, fishing and farming and raising their families, without anyone telling them that the unusual frequency of certain haplogroups in their Y chromosome data or the elevated WHG ancestry in their autosomal DNA profiles makes them among the most genetically significant populations in all of Europe. Now, we need to go further back than even the Neolithic, further back than the megalith builders and the Atlantic coastal farmers, all the way back to the moment when Britain first became inhabitable after the last glacial maximum, because the genetics of the Scottish Islands do not begin with the people who built Callanish or Skara Brae. They begin with the people who were the first to return to Britain after the ice retreated, the people who walked back into a landscape that had been uninhabitable for thousands of years and who set the initial genetic template on which everything that came afterward would be layered. The last glacial maximum, the period of maximum ice extent during the most recent ice age, peaked roughly 21,000 years ago. At that point, Britain was not habitable in its northern reaches. The entire northern half of the British landmass was under ice, and the southern half, though not glaciated, was an Arctic steppe environment, treeless and cold, supporting populations of mammoth and woolly rhinoceros and other cold-adapted megafauna, but challenging for human habitation. The human populations of Britain during this period were sparse, possibly absent entirely in the coldest phases, and whatever populations had been present before the glacial maximum had mostly retreated southward to refugia in southwestern France, northern Iberia, and the Mediterranean coast, the places where the climate remained just barely compatible with human survival. As the ice began to melt and the climate gradually warmed, these refugial populations began to move northward. The recolonization of Britain after the last glacial maximum was not a single event. It happened in waves, over thousands of years, as different ecological zones re-established themselves and made the landscape habitable for the hunter-gatherer populations that were expanding out of their southern refugia. The first wave of recolonization appears to have come largely from southwestern France and northern Iberia, the same refugial zone that had sheltered populations through the coldest part of the glacial period. These were the people who brought into Britain the genetic profile that researchers identify as Western hunter-gatherer ancestry, and they were the genetic ancestors of the populations who would be displaced or mixed with by the later Neolithic farming expansion. But here is the part that most accounts of British prehistory gloss over. The Iberian refugial populations that recolonized Britain and Ireland after the Ice Age were not a single genetically uniform group. They were themselves the product of thousands of years of development in a geographically diverse region, shaped by the specific conditions of Atlantic Iberia, by their exploitation of the rich coastal and riverine environments of what is now Portugal and northwestern Spain, and by whatever contacts they had maintained or developed with populations further south in Africa, with populations moving along the Atlantic coasts from different directions, with whoever else was living in the geographic neighborhood of their refugia during the long, cold millennia they spent there. The genetics of the Atlantic Iberian refugial populations are not identical to the genetics of the populations that sheltered in other European refugia in southeastern Europe or the Balkans or the eastern Mediterranean. They had their own evolutionary history, their own genetic distinctives, and when they moved northward into Britain and Ireland, they brought those distinctives with them. The North African connection that shows up in studies of Irish and Scottish island genetics is one of the most discussed and most debated aspects of this population history. There are ancient genetic signals in certain Atlantic island populations that researchers have interpreted as reflecting a connection to North African populations, not a recent admixture from the historic or medieval periods, but something much older, something that might reflect either shared ancestry between Atlantic Iberian refugial populations and their counterparts in the Maghreb, the North African coastal zone that faces toward Iberia across the Strait of Gibraltar, or some degree of actual population movement across that strait in the distant past. The Strait of Gibraltar is only 14 kilometers wide at its narrowest point, in a world where Atlantic islanders were making sea crossings of significantly more than 14 kilometers to maintain connections between the islands of the Hebrides and Ireland and Brittany. The idea that coastal populations in Iberia and North Africa were in contact across the Strait of Gibraltar does not require any exotic technology or any particular heroism. It requires only boats of the kind these populations demonstrably had, and a reasonable motivation, whether that motivation was trade or marriage or the simple human impulse to see what is on the other side of a body of water that you can see across from the beach. The Berber populations of North Africa, the indigenous North African peoples who are not Arab by ancestry but who represent a much older stratum of North African population, show genetic affinities with European Atlantic fringe populations that have been noted in multiple studies and that cannot be entirely explained by later historical contacts between Europe and North Africa. The Berbers have their own language family, the Afro-Asiatic Berber languages, which are completely unrelated to the Indo-European languages of Europe and also unrelated to the Semitic languages of the Middle East, and they carry certain haplogroup frequencies, particularly in mitochondrial haplogroup H subclades, that mirror patterns seen in Atlantic fringe European populations in ways that suggest shared ancestry rather than independent convergence. The Berbers of Morocco and Algeria, particularly those from the more isolated mountain communities of the Atlas Ranges, are one of the populations most cited in discussions of the ancient North African-European Atlantic connection. This is not a well-publicized connection. It does not fit neatly into the narratives of either European identity or North African identity that have developed in the modern period. And so it tends to get mentioned briefly in academic literature, and then left aside in favor of discussions that feel less challenging to received ideas about where European populations come from and how they got there. But the genetic signal is real, and it is most visible in the populations of Britain and Ireland that show the highest WHG and Atlantic Neolithic ancestry percentages, which are, again, the Atlantic island and fringe populations. The dark complexion traits that outside observers have consistently noted in these populations, the olive skin tones that seem paradoxical at the latitude of the Outer Hebrides, may reflect not just the general WHG tendency toward darker pigmentation, but specifically the North African or Southern connected ancestry that flowed into these populations through the Atlantic-Iberian refugial route, and that was not diluted by the lighter-skinned incoming populations as thoroughly in the islands as in the mainland. The story gets still more complex when you add the Irish component, because Ireland is not simply another Atlantic island in genetic terms. It is the Atlantic island with the highest concentration of ancient genetic ancestry in its population, and the Irish contribution to the genetics of the Scottish Islands through the medieval Gaelic settlement of the Western Islands, and the Dalriata kingdom that linked northeastern Ireland and southwestern Scotland in the early medieval period, added another stream of deeply ancient Atlantic ancestry into the already old genetic substrate of the Scottish Atlantic fringe. The ancient DNA from Irish megalithic tombs has revealed a population with unusually high WHG ancestry, even by Atlantic standards, a population that appears to have been more isolated than even the British Atlantic coastal populations from the later incoming populations of the Neolithic expansion, possibly because Ireland was reached by the farming wave later than Britain or in smaller initial numbers. The Irish Neolithic population retained its old genetic baseline more thoroughly than its British counterpart, and when the Irish and Scottish populations began their historical period of deep connection and intermixture, the Irish contribution to the Scottish island gene pool brought with it a reinforcement of the very ancient genetic signals that were already present there. There is a genetic marker associated with Irish population history that appears at such elevated frequency in certain Irish populations and their Scottish island relatives that researchers have given it its own name, the Irish modal haplotype. This is a specific configuration of the Y chromosome haplogroup R1b, the haplogroup brought by the Bronze Age steppe migrations, but in a subclade that is more specifically associated with the Atlantic coastal populations, and that appears at its highest world frequencies in Ireland and in the Scottish Islands and western coasts that received Irish genetic input. The paradox of the Irish modal haplotype is that it is a R1b marker, which means it came with the Bronze Age steppe migrations, but it has become so concentrated in the Irish population through the specific demographic history of Ireland, which involved its own sequence of population contractions and expansions, that it now serves as a marker of Irish identity, even though its ultimate origin was in the steppe migrations from Central Asia. The populations that carry it most heavily, the Irish and the Scottish Islanders with strong Irish ancestry, show phenotypic traits that do not simply reflect their steppe-derived patrilineal ancestry. They also reflect their ancient Irish Atlantic maternal ancestry, the mitochondrial lineages and autosomal ancestry profiles that they carry alongside the Irish modal haplotype and that connect them to the deep substrate of the Atlantic world. This is a good illustration of why simple haplogroup narratives, stories that focus only on Y chromosome data or only on mitochondrial data, always miss something important. The full picture requires looking at the whole genome, and when you do that for the Atlantic island populations, what you see is a layering of ancestries that spans the entire post-glacial history of Europe, with the oldest layers most visible in the most geographically isolated populations. The Norse arrival is the most recent major genetic event in the history of the Scottish Islands, and it deserves its own careful discussion because it is often treated as if it were the primary fact of island genetic history, the thing that most defines the genetics of Orkney and Shetland and the Hebrides, when in fact it is better understood as the most recent layer laid over a much older and much more complex substrate. The Norse did arrive, in significant numbers, particularly in Orkney and Shetland. The genetic signal of Norse settlement in these islands is among the strongest of any Viking Age population movement documented by ancient DNA research in the British Isles. Studies using ancient DNA from Norse period burials in Orkney and comparing it with modern Orcadian DNA have found that somewhere between 20 and 30% of Orcadian ancestry traces to Norse settlers, a substantial contribution that is reflected in everything from place names to some aspects of the traditional law system, the Udal law of Orkney and Shetland, that has Norse rather than Scottish legal roots. But 20 to 30% Norse ancestry means 60 to 80% non-Norse ancestry. It means that when the Norse arrived in Orkney and Shetland, they were not arriving into an empty landscape. They were arriving into a landscape populated by Pictish communities, whose ancestry, as we have seen, blended ancient WHG inheritance with Atlantic Neolithic contributions and Bronze Age steppe-derived genetics, and who had been living on these islands, maintaining and adapting to their specific environments for thousands of years before a single Viking longship appeared on the horizon. The Norse intermarried with these existing populations, as evidenced by the genetic mixing that is visible in the ancient DNA from the settlement period, and the result was not a replacement of the existing population but an addition to it, a new genetic stream flowing into the ancient pool and mixing with it in proportions that varied by island and by community, and that left the oldest genetic signals not replaced but diluted, still present, still detectable, still expressed in the population to varying degrees even today. The Hebrides tell a somewhat different story than Orkney and Shetland. The Norse impact on the Outer Hebrides was significant culturally and linguistically, but the genetic data suggest it was somewhat less numerically overwhelming than in the Northern Isles. The Outer Hebrides received Norse settlement, which is why Old Norse place names appear throughout the islands, from Lewis in the north to Barra in the south, but they also received, in the medieval period, the Gaelic Irish influence of the Lordship of the Isles, the Gaelic cultural and political revival that swept the Western Islands in the later medieval period, and that reinforced the Gaelic linguistic and cultural character of the Hebrides, while the Northern Isles retained their more distinctly Norse cultural identity. The genetic consequence of this different history is that the Outer Hebrides show a genetic profile that is, in some respects, more ancient than that of the Northern Isles, with higher proportions of the deep Atlantic, Neolithic, and WHG ancestry relative to Norse-derived genetics, even though the Norse did reach and influence these islands as well. This variation within the Scottish Islands, the different proportions of ancient and recent ancestry in different island groups, is itself part of the story of why island populations look different from each other as well as from mainland populations. Someone from Shetland and someone from the Outer Hebrides will show recognizable differences in genetic profile, even though they are both, by any national or ethnic categorization, Scottish Islanders. The Shetlander carries more Norse ancestry. The Hebridean carries more of the ancient Atlantic substrate. And these differences in genetic composition express themselves, to varying degrees, in physical appearance and in cultural practice, and in the way these communities have understood themselves historically. The question of what the pre-Norse population of Orkney and Shetland actually looked like, ethnically and linguistically, is one of the most interesting unanswered questions in early Scottish history. By the time we have any written record that mentions the Northern Isles, they are already described as Pictish territory. But the Picts of the Northern Isles may have been themselves a relatively recent overlay on an even older population, the descendants of the Neolithic communities that built the Nap of Howard on Papa Westray, the oldest standing stone house in northern Europe, dating back to before 3500 BCE. The Nap of Howard predates Skara Brae. It predates Stonehenge. It is a building erected by people who had been living on these islands long enough to have developed a sophisticated, settled lifestyle, and the people who built it were not Picts in any historical sense. They were whatever came before the Picts. The Neolithic islanders whose genetics and cultural traditions the Picts may themselves have inherited and transformed over the millennia between the abandonment of the Neolithic culture and the emergence of the historical Pictish period. The continuity between the Neolithic islanders and the Picts is one of those questions that ancient DNA research is in the process of answering, slowly and incompletely. The preliminary evidence suggests that there was significant continuity, that the Bronze Age migrations that so dramatically altered the genetics of southern England had a less thorough impact on the Northern Isles, and that the populations of Orkney and Shetland in the Iron Age and early medieval period carried measurably more ancient ancestry than their counterparts in most of Britain. This would mean that the people whom the Norse encountered when they arrived in Orkney were themselves the bearers of genetics that stretched back in some proportion to the Neolithic builders of Skara Brae and the Nap of Howard, people who were already ancient by any standard when the Norse longships appeared. And it would mean that the Norse genetic contribution to modern Orcadian and Shetlandic populations was mixed into a substrate that already contained in elevated proportions the oldest genetic signals in the British Isles. The Norse, in other words, did not create the genetic distinctiveness of the Scottish Islands. They found it already there. They added to it. They modified it. They contributed a significant and distinctive new strand to the genetic tapestry. But the tapestry was already woven, already ancient, already carrying within it the accumulated genetic history of the Atlantic world. The Norse are the newest thread in that tapestry, and the most visible to anyone who looks at the history of these islands with the traditional tools of documentary history, because the Norse left texts and laws and place names and chronicled sagas, while the Picts left symbols carved in stone and the Neolithic islanders left bones and monuments, and the WHG ancestors left only their genetic signatures, detectable now by technology they could not have imagined, invisible to every historian who tried to understand these islands before the tools of ancient DNA research became available. The Isle of Man deserves its own moment in this investigation because it sits at the centre of the Irish Sea, equidistant from Ireland, Scotland, England, and Wales, and its genetic history reflects its position as a crossroads of the Celtic world in a way that makes it a useful lens for understanding the genetic complexity of the British Atlantic fringe more broadly. The Isle of Man was inhabited in the Mesolithic period, recolonized by Neolithic farming communities in the typical pattern of the Atlantic Neolithic, modified by Bronze Age steppe-derived migrations, and then shaped in the early medieval period by waves of Irish and Scottish Gaelic settlers, Viking Norse settlers, and eventually by English-speaking influences from the mainland. Its traditional language, Manx, is a Gaelic language closely related to Scottish Gaelic and Irish, but with its own distinctive phonology and vocabulary that reflects the island's specific history of influences. Manx was declared extinct in 1974 when its last native speaker died, but has since been revived through dedicated community efforts and now has several hundred fluent speakers, a reminder that language death is not always permanent if a community cares enough about its linguistic heritage to do the work of revival. The genetics of the Manx population show a distinctive profile that reflects the island's position and history. There is elevated Irish-Celtic ancestry, reflecting the early medieval Irish settlement that was probably the most numerically significant of the historical population movements to the island. There is Norse ancestry from the Viking period, when the Isle of Man was part of the Kingdom of the Isles and served as a strategic hub in the Norse maritime network of the Irish Sea. And underneath both of these, in proportions that are elevated compared to mainland English populations and more comparable to Western Scottish and Irish populations, there is the ancient substrate, the WHG and Atlantic Neolithic ancestry that connects the Manx population to the broader Atlantic world, of which their island is a geographic part. The Isle of Man is small enough and sufficiently isolated by the Irish Sea that each of these waves of settlement mixed with the existing population rather than replacing it, and the result is a genetic profile that layers Celtic, Norse, and ancient Atlantic ancestry in proportions unique to this specific island at this specific crossroads. What all of these island case studies share, from Orkney to Shetland to the Hebrides to the Isle of Man, is the basic principle that island geography creates genetic distinctiveness by moderating the flow of new genetic material into an existing population. Each wave of migrants to arrive on an island arrives in a context where they are already surrounded by the existing islanders. They do not come in sufficient numbers to overwhelm the existing population. They mix, they contribute their genetics to the pool, but they do not replace what was there before. And over time, this selective accumulation of new genetic contributions onto an old and persistent base creates population profiles that are genuinely distinctive, that carry within them archaeological records written in DNA, records that extend further back in time than any monument or any text or any named historical tradition. It is worth pausing here to address a question that sometimes comes up when people encounter this material for the first time. The question is whether any of this genetic distinctiveness maps onto cultural or cognitive traits, whether the ancient genetics of the Atlantic island populations express themselves in ways beyond the physical appearance that we have been discussing. The answer is nuanced and requires care to state properly, because this is a domain in which pseudoscience has done tremendous damage and continues to do damage wherever it is allowed to operate without scrutiny. The cultural distinctiveness of the island communities is real, but it is a cultural and historical achievement, not a biological one. The Gaelic literary tradition of the Hebrides, one of the oldest and richest oral and written literary traditions in Europe, reflects centuries of cultural development in a specific environment and a specific community. The music traditions of Orkney and Shetland, with their distinctive fiddle styles and their connections to both Norse and older Celtic traditions, are the product of cultural evolution in a place where multiple influences arrived and were integrated into something new. The architectural traditions, the fishing practices, the agricultural adaptations to challenging island environments, all of these are human achievements, the products of intelligence and creativity and adaptation over time, not the expression of some biological essence encoded in the ancient haplogroups that these populations happen to carry. What the genetics do tell us is something more interesting than any hierarchy. They tell us that the people living on the Scottish Islands today are the descendants of some of the earliest inhabitants of their islands, that they carry within their cells a record of population history extending back to before the Neolithic, and that this record is legible to modern science in ways that allow us to understand, better than any generation before us has been able to, the deep history of these communities and of the Atlantic world they represent. That is remarkable enough on its own terms, without any need to inflate it with implications about superiority or destiny or the mystical significance of bloodlines. Now we have to return to the haplogroup X connection, because we have been circling around it and the time has come to look at it directly. The presence of haplogroup X in elevated frequencies in both Atlantic European island populations and certain Native American populations is one of those facts in population genetics that generates a disproportionate amount of attention, precisely because it does not fit neatly into the standard models of human migration, and disproportionate attention is exactly what it has received, from both legitimate researchers trying to understand what it means and from people who are not scientists but who have found in the data a hook for narratives about lost civilizations, ancient mysteries, and pre-Columbian contact between Europe and the Americas that they find compelling for reasons that have more to do with their pre-existing beliefs than with what the data actually supports. Let us start with what the data actually says and then look at the interpretive question seriously. Haplogroup X is a mitochondrial haplogroup, meaning it is passed only through the female line and reflects only the maternal ancestry of the people who carry it. It is divided into several subclades, with X1 being primarily African and Middle Eastern in distribution and X2 being primarily European and Near Eastern. Within X2, there are several subclades, and the most relevant for this discussion are X2A, which is the form found in Native American populations, and various X2B and X2C subclades that are more common in European populations. The key fact that makes X2A interesting is that it is not the same subclade as the X2 forms found in European populations. It is a derived subclade, meaning it descended from an ancestral X2 lineage but accumulated additional mutations that distinguish it from the European forms. This has two implications. First, it means that the X2 in Native American populations and the X2 in European populations share a common ancestor but are not identical, and that common ancestor probably lived many thousands of years ago. Second, it means that the distribution of X in Native American populations is not simply a recent contamination from European-descended populations in the Americas, because the X2A subclade is genetically distinct from the European X2 forms that would have been introduced by post-Columbian European migration to the Americas. The question is where the ancestral X2 lineage that gave rise to X2A came from, and when it entered the Americas. Under the standard Beringian model, the ancestors of Native Americans left Siberia and entered the Americas via the Bering Land Bridge at least 15,000 years ago, possibly earlier, and spread south and east across both continents. The problem for the Beringian model of X2A is that X2, in its various forms, is essentially absent from Siberia and from East Asian populations generally, which are the presumed source populations for the Beringian migrants. X is present at low frequencies in some Central Asian and South Asian populations, but not at frequencies that would easily explain its elevated presence in specific North American populations, particularly given the geographic pattern of its distribution within the Americas. X2A is concentrated in the northeastern part of North America, in populations including the Ojibwe, the Oneida, the Nu-Chah-Nulth, and several other groups. It drops to very low or absent frequencies in South American indigenous populations and in many Western North American populations. This is not the distribution you would expect if X2A entered the Americas with the initial Beringian migration, which would have populated the Americas from west to east and south, with the northeastern populations receiving the founding lineages later rather than earlier. The Solutrean hypothesis, first proposed in its genetic form by researchers including Brian Sykes and later developed by others, suggests that haplogroup X2A may have entered the Americas via a transatlantic route, carried by people moving from the Iberian Atlantic coast along the margin of the North Atlantic ice sheet during or just before the last glacial maximum. This is a hypothesis, not a proven fact, and it has significant problems that need to be acknowledged honestly. The Solutrean culture of southwestern Europe and northern Iberia, which flourished between roughly 25,000 and 17,000 years ago, did show some technological parallels with the Clovis culture of North America that some archaeologists have found suggestive of a connection, though others have argued these parallels are superficial and that similar technologies could have been developed independently. The main problem with the Solutrean hypothesis is the one we have already noted with respect to the specific subclade differences between European X2 and American X2A. If European populations contributed X2A to the Americas via a transatlantic route, you would expect the X2 forms in Atlantic European populations to be more similar to X2A than they are. The subclade distinction makes a simple European origin for X2 less straightforward than the hypothesis requires. But the hypothesis has not been definitively refuted either. The ancient DNA record for European populations before the Neolithic is sparse, and we cannot be certain that the X2 haplogroup forms present in pre-Neolithic Atlantic European populations, including the WHG populations that are ancestral to the elevated X frequencies seen in modern Atlantic island populations, were exactly the same as the forms we find in modern European populations. Some researchers have suggested that the pre-Neolithic European X2 pool may have been more diverse than the modern record suggests, and that X2A, or something closely ancestral to it, may have been present in those ancient populations before being reduced in frequency by the subsequent Neolithic and Bronze Age demographic transformations. If this is correct, and it is currently neither confirmed nor refuted, then the elevated X frequencies in modern Atlantic island populations, where the oldest European genetic layers are most visible, might be a window into a haplogroup diversity that once existed more broadly in the European population and that has survived at higher frequencies in the most isolated Atlantic populations. And a transatlantic migration that carried one variant of that diversity, perhaps carried by people following food sources along the ice margin route from Europe to North America, might have brought X2A to the Americas before the other, more easterly routes of entry were possible. This is speculation, clearly labelled as such, but it is the kind of speculation that is grounded in real observations about real data, and it deserves to be taken seriously as a hypothesis, even while being held at arm's length from the status of established fact. The genetic connection between Atlantic European island populations and certain Native American populations is a real observation. The mechanism that produced it remains genuinely uncertain. And the uncertainty is not a failure of science, but an honest acknowledgement of the limits of what we currently know. What the Solutrean hypothesis and its variants have unfortunately generated in the popular reception of this material is a great deal of misuse by people who want to claim that Native Americans are actually descended from Europeans, or that European populations have a kind of priority claim to the Americas that invalidates the deep indigenous history of the American continents. This is a misreading that requires willful ignorance of the actual data to sustain, since even the most aggressive version of the Solutrean hypothesis posits only a minor and partial contribution to specific North American founding populations, while the overwhelming genetic ancestry of Native American peoples traces to Asian-derived populations via Beringia. But the misuse of the data does not invalidate the data, and the legitimate scientific question about haplogroup X distribution deserves to be discussed seriously without either the false amplification of people with agendas or the dismissive silence that sometimes results from discomfort with how the material gets misused. The reason this is relevant to the story of why Scottish Islanders look different is that the elevated X frequencies in Atlantic island populations and the genetic connection those frequencies imply to ancient population movements across the Atlantic world are part of the same broader story about the deep antiquity and global connectedness of the Atlantic fringe gene pool. The Scottish Islanders are not just relics of a local European prehistory, they are nodes in a network of ancient human movement and genetic exchange that spanned the North Atlantic and connected populations from Iberia to the Scottish Islands to possibly the eastern coasts of North America in ways that predate any written history by thousands of years. Whether the specific X2, a connection to Native Americans, reflects a real transatlantic population movement or some other mechanism, the fact that Atlantic European island populations show elevated X frequencies that are anomalous compared to the rest of Europe tells us that their gene pool contains something that is not simply explained by the standard narrative of European population history. It tells us that they are the heirs of a genetic tradition that is older, stranger, and more globally connected than the neat frameworks of Celtic and Norse ancestry would suggest. Let us now turn to a topic that is adjacent to the genetics, but that illuminates a different dimension of what makes the Atlantic island communities distinctive. The cosmological and spiritual traditions of the pre-Christian island peoples, the traditions that shaped the lives of the people who built Callanish and Skara Brae and the passage tombs of Orkney, were not the traditions of the Celts. They were older than the Celts. And some of the fragments of those older traditions that survived into the historical period, embedded in the folk practices and oral narratives and place name traditions of the islands, point toward a worldview that shares features with traditions from places as far away as the Caucasus and the Levant and, once again, the indigenous traditions of the Americas. The stone circles and megalithic tombs of the Atlantic world were not simply burial monuments, though they do contain burials. They were oriented, consistently and precisely, to astronomical events, the solstices and equinoxes, the rising and setting of specific stars, the extreme southerly moonrise that the main alignment at Callanish tracks through its stone avenue. The people who built these monuments were documenting the movements of celestial bodies, and they were doing so in ways that required multi-generational observational programs, sustained attention to the sky over periods of decades, and the ability to encode and transmit that astronomical knowledge across generations in forms that allowed each new generation of builders to pick up where the previous one had left off. This is not primitive. This is the same intellectual enterprise that produced the astronomical calendars of ancient Mesopotamia and Egypt, and it was happening in Orkney 5,000 years ago. At the same time, it was happening in the Nile Valley and the Tigris-Euphrates basin, with no documented contact between these traditions, because the sea routes that connected the Atlantic world were not the same routes that connected the Atlantic world to Mesopotamia. The Orcadian Neolithic tradition that produced Skara Brae and the Ring of Brodgar and the stones of Stenness and the great passage tomb at Maeshowe did not simply vanish. It was modified, transformed, absorbed into new cultural frameworks as Bronze Age and Iron Age cultures layered themselves over it. But fragments of its cosmological worldview persisted in the folk traditions of the Northern Isles in ways that researchers studying Scottish Island folklore have found to be genuinely anomalous, not matching the folklore of mainland Scotland or England or Scandinavia in their specific content, pointing toward an older substrate of belief that predates the Norse and even the Pictish overlay. The traditions around certain standing stones on Orkney, the specific folk beliefs about the orientation of houses and graves toward particular compass points, the practices around certain seasonal festivals that do not map neatly onto either the Celtic or the Norse festival calendars, these are the traces of a cosmological system that was already very old when the Picts carved their symbols onto stone and the Norse arrived in their longships. The Irish traditions offer a useful parallel here, because Ireland preserved more of its pre-Christian cosmological material in written form than any other part of the British Isles, thanks to the early medieval Irish monastic tradition that compiled texts recording indigenous oral traditions, even as it also promulgated Christian doctrine. The texts collected in the medieval Irish manuscripts, particularly those relating to the mythological cycle and the stories of the Tuatha De Danann, contain material that many researchers believe preserves, in heavily mythologized form, genuine cultural memories of the Neolithic and possibly even the Mesolithic period. The stories of underground worlds, of beings who inhabited the land before the Celts arrived and who retreated into the fairy mounds, the ancient burial cairns and passage tombs when the new people came, the stories of immortal beings who are connected to specific places, specific landscapes, specific astronomical orientations. These are not Celtic inventions. They are adaptations of much older traditions, traditions that the Neolithic peoples of Ireland carried, traditions that the megalithic monuments they built embody in stone, and traditions that survived into the Celtic period precisely because the people who built the monuments and maintained the traditions did not simply disappear when the Celts arrived. They mixed with the new arrivals, as we have seen in the genetics, and their traditions mixed with the new traditions, producing the hybrid mythological system that we know as Irish mythology. The parallel between this process in Ireland and the same process in the Scottish Islands is striking. In both cases, very ancient indigenous traditions were modified by incoming populations, but not replaced entirely. In both cases, fragments of the older cosmological system survived into the historical period in forms that are recognizable as different from the dominant Celtic or Norse traditions that overlay them. And in both cases, the people who carry the most elevated proportions of the ancient genetic ancestry are also the people in whose communities these traces of the older traditions are most persistently found. The correlation is not perfect, because cultural transmission and genetic transmission are different processes that do not always align. But the correlation is real enough to be noticed, and it points toward the same general conclusion that the genetic data points toward. The Atlantic island communities of Britain and Ireland are not simply late-arriving Celtic and Norse populations inhabiting a landscape that was previously empty. They are the descendants of the people who have been on these islands the longest, who built the oldest monuments, who maintained the oldest traditions, and who have preserved more of the deep population history of Western Europe than almost anyone else on the continent. Before we move to the conclusion of this investigation, there is one more dimension of the island distinctiveness story that deserves attention. It is the dimension that ordinary people in these communities have been aware of, in their own ways, without the vocabulary of haplogroups and ancient DNA. It is the lived experience of being recognizably different, of being understood by the communities they live in as carrying something old and particular, something that connects them to the specific landscape and history of their islands in ways that newcomers and outsiders do not share. The Scottish island communities have their own strong traditions of genealogical memory, of tracing descent through multiple generations in ways that are taken seriously as social identity markers. This is not unique to these communities, but it has particular salience here because the communities are small enough and have been historically stable enough. That genealogical memory is actually possible in ways that it is not in large urban populations where records are fragmentary and family connections are quickly lost. On Orkney, it is not unusual for people to be able to trace their family connections on the islands back through 5 or 6 or more generations of documentation, and for that traceable genealogy to be supplemented by oral traditions of much greater depth. The awareness that certain family lines have been on the island for a very long time, that they connect to specific farming communities and fishing villages that have been in the same locations for generations, is part of the texture of daily life in these communities, in ways that are not simply nostalgic, but that reflect genuine continuities of place and ancestry. When commercial genetic genealogy companies first started offering DNA testing services to the general public in the early 2000s, the results that Scottish island populations received when they tested were often striking precisely because they documented ancestral connections that felt both expected and surprising at the same time. Expected because island communities are aware of their distinctiveness. Surprising because the documentation often showed just how ancient and deep that distinctiveness runs, connecting people to population groups that predated any name or cultural identity they had learned in school. The results showing elevated WHG ancestry, the haplogroups that trace to pre-Neolithic Europe, the unexpected connections to populations in geographically distant regions that make sense only when you know the deep history we have been tracing. All of these resonated with something that people in these communities often already felt, that they are connected to their islands and to each other in ways that run deeper than any conventional narrative of British history can account for. This is not mysticism. It is not romantic nationalism. It is people recognizing in the language of genetics something that their community experience had already told them in other languages. The genetic data is the most precise and most recent tool for understanding what that experience means historically. But the experience itself, the sense of deep-rootedness in a specific place, the recognition of shared ancestry with specific communities across the sea routes of the Atlantic world, the awareness of carrying something ancient, was there long before anyone sequenced a genome. It was there in the stories. It was there in the music. It was there in the faces of the people who have been standing on these island cliff tops watching the Atlantic for longer than most of Europe has been farmed. The scientific story and the human story are the same story, told in different registers. The haplogroups and the ancient DNA percentages and the refugial persistence models are the scientific register. The genealogical traditions and the folk memories and the persistent physical distinctiveness that outside observers have been commenting on for centuries are the human register. Both registers are pointing at the same thing, the same deep history, the same ancient population, the same connections across the Atlantic world. And the most interesting thing about the moment we are now living in, the moment when ancient DNA research has made this deep history legible in ways it has never been before, is that for the first time in the history of these communities, the scientific tools exist to confirm what the human experience has always suggested. The people of the Scottish Islands, the Orcadians and the Shetlanders and the Hebrideans and the Irish and the Manx are not just a subset of the British and Irish populations with a distinctive regional flavour. They are the guardians, in a biological and cultural sense, of the oldest continuously inhabited human communities in the British Isles. Their genetics trace back in measurable and documented ways to the people who were on these islands first, who built the first monuments, who maintained the first communities, who watched the Atlantic from the first cliff tops. That is a heritage of extraordinary depth and significance, and it is one that has been available to see, in those distinctive faces, in those dark eyes at unexpected latitudes, for as long as anyone has been paying attention. There is a question that runs underneath everything we have been discussing, a question that the genetics and the archaeology and the folklore can gesture toward but cannot answer definitively on their own. It is the question of what the Atlantic world, the connected maritime civilization of the Neolithic and early Bronze Age, actually was. Not in the limited sense of a set of archaeological culture complexes with shared stylistic features and documented trade connections, but in the fuller sense of what it meant to be part of it. What did people know about the shape of their world? How far did their networks actually extend? What was the outer limit of the human geography that an ordinary person living on Orkney or in the Outer Hebrides 5,000 years ago would have recognized as their world? We know some things about the extent of these networks from the material evidence. We know that specific types of stone, including the Langdale tuff from the English Lake District, was being quarried and exchanged as polished stone axes across networks that spanned the length and breadth of Britain during the Neolithic period. We know that the bluestone at Stonehenge, the smaller standing stones in the centre of the monument, were transported from the Preseli Hills of Wales to Salisbury Plain, a distance of roughly 240 kilometres, and that this transport was deliberate and purposeful, involving selection of specific geological types from specific locations in the Welsh landscape. We know from the genetic evidence that there were connections between the megalithic communities of the Hebrides and those of Ireland and Brittany, that imply not just occasional contact, but sustained relationships across the sea. Routes. We know that materials, including amber from the Baltic, faience beads from the Mediterranean, and gold from Ireland, were circulating in exchange networks that connected communities across the full breadth of Europe during the Bronze Age, which itself overlapped with, and in some regions grew out of the late Neolithic Atlantic world. The scale of these networks is genuinely staggering when you hold it up against the simplistic picture of isolated primitive communities that most people carry around as their mental model of prehistoric life in Britain. People 5,000 years ago were not simply living in small, locally isolated groups, making do with whatever resources their immediate territory provided, unaware that other communities existed beyond walking distance. They were embedded in networks of exchange and interaction that spanned thousands of kilometers, that connected communities speaking different languages across the Atlantic facade of Europe, that brought raw materials from distant sources into local craft traditions that processed and transformed them and sent the resulting objects back out into the networks for further distribution. This was not civilization in the urban sense that the word usually carries. There were no cities. There was no writing, as far as we know. There were no bureaucratic states, but there was complexity, there was organization, there was a level of coordination across large distances and multiple communities that required knowledge, planning, and some kind of shared framework of understanding and expectation that we can only partially reconstruct from the material evidence. The stone circles are part of the evidence for this shared framework. The architectural principles that govern the design of Callanish in the Outer Hebrides are recognizably related to the principles governing the design of the stone circles at Avebury and Stonehenge in Wiltshire and the stone circle tradition more broadly across Britain and Ireland. The astronomical alignments, the use of specific stone types, the relationships between circles and avenues and burial monuments in the surrounding landscape, these all reflect a shared intellectual tradition about how to build sacred spaces and how to orient them relative to the cosmos. This shared tradition was not the result of one community inventing the principles and then spreading them to others in a single wave of cultural diffusion. It was a tradition that developed over centuries, that was refined and elaborated by different communities in different places, and that maintained its coherence across a wide geographic area because the communities involved were in contact with each other, exchanging ideas and practices, and possibly personnel along the same routes that carried the amber and the faience and the Langdale axes. When you understand the Atlantic world in these terms, as a connected network rather than a set of isolated communities, the genetic connections we have been discussing take on a different significance. The elevated shared ancestry between the Scottish Islands and the Irish and Breton megalithic communities is not just a historical accident of geography. It reflects sustained human contact across the sea routes, a contact that involved not just the exchange of goods, but the movement of people, marriages between communities, individuals who travelled from one island to another and stayed, children of mixed parentage who combined the genetic heritages of their parents' communities and who themselves had children who combined genetic heritages further. The genetic connections are the biological record of a social world, and the social world they record was richer and more extensive than most people imagine. The passage tombs of Orkney are particularly interesting from this perspective. Maeshowe, the great chambered tomb on the Orkney mainland, is aligned so that the midwinter sunset illuminates the back of the main chamber through the entrance passage, a phenomenon that occurs only around the winter solstice, and that was clearly intentional on the part of the builders. This is the same principle as the more famous alignment at Newgrange in Ireland, where the midwinter sunrise illuminates the inner chamber through a carefully designed roof box above the entrance. The Irish and Orcadian passage tomb builders shared an astronomical concept, the same idea of marking the solstice by designing a monument so that the sun's light reaches the most sacred interior space on the most cosmologically significant day of the year. Either this concept travelled from one community to the other across the sea routes, or it was independently invented in two places by communities working within the same intellectual tradition. Either way, it is evidence of connection, of a shared framework of ideas about the relationship between architecture, astronomy, and the sacred. The people who inherited this framework, the descendants of the megalith builders who maintained and modified these traditions through the Bronze Age and the Iron Age and into the historical period, were not forgetting what their ancestors had built and understood. The monuments were still there. They were still being used, in modified ways, in later periods. Meisho was entered by Norse settlers in the 12th century CE, as documented by the largest collection of Viking-age runic graffiti anywhere in the world, carved on the interior walls of a chamber built 3,000 years before the Norse arrived. The Norse who carved those runes were clearly impressed by the monument, clearly aware that it was the work of people who came before them, clearly using it as a space with significance, even if their understanding of that significance was different from the understanding of the people who built it. The monument endured, the landscape endured, and the people, mixing and changing, and adding new populations to the ancient substrate, endured too. Now, let us look at the linguistic evidence, because language is the dimension of this story that is most legible to non-specialists, and that most clearly illustrates the persistence of the pre-Celtic substrate in the British island communities. We have already discussed the Pictish language mystery and the question of whether it represents a pre-Indo-European survival. But the evidence for the ancient substrate in the languages of the Atlantic islands, extends beyond Pictish into the Gaelic and Brythonic languages that eventually came to dominate these communities, and into the place names that preserve, fossilized in the landscape, traces of whatever was spoken here before the Celtic languages arrived. Place names are the most conservative linguistic data available to researchers studying ancient languages. A hill or a river or a headland acquires a name from the first people who live near it and need to refer to it, and that name tends to stick, even when the community that coined it is replaced by a community speaking a different language. The incoming community does not always know what the original name means, but they hear the existing inhabitants using it, and they adopt it, possibly adapting it phonologically to fit their own sound system, but preserving the basic form because names are proper nouns, and proper nouns resist translation. This is why you find river names in Britain that are so old that they predate not just the Norse and the Romans and the Celts, but possibly any language family currently surviving. The name Thames, for the river that runs through London, has no clear etymology in any Celtic or Germanic language and has been suggested by some linguists to reflect a pre-Indo-European root. The name Avon, which appears on rivers all over Britain, comes from a Celtic word meaning river, which suggests that the rivers it names had pre-Celtic names that the incoming Celtic speakers replaced with a simple, generic term rather than adopt the older name. What the older names were, we cannot now say. On the Scottish Islands, the place name evidence is layered in exactly the way you would expect, given the population history we have been tracing. The oldest stratum of names, the ones that do not yield to etymology in any known language, are present, but sparse, preserved mainly in the names of certain topographic features that were named long before the Pictish period. Above them is a Pictish stratum, place names that can sometimes be partially interpreted using the limited Pictish vocabulary that linguists have assembled. Above that is the Gaelic stratum, the names given or modified by Gaelic-speaking settlers from Ireland and from the mainland Gaelic-speaking regions of Scotland. And on top of that, particularly in the Northern Isles, is the dense Norse overlay that gave Orkney and Shetland the majority of their current place names. Mainland, Hoy, Stromness, Kirkwall, Lerwick, Fair Isle, these are all Norse names, or names with significant Norse modification, and they sit above multiple earlier strata of naming that are still partially visible if you know how to look for them. The persistence of the pre-Gaelic, pre-Norse substrate in the island communities is not just visible in a few archaic place names. It is also visible in certain features of the Gaelic spoken on the islands, dialects that, in some cases, preserve phonological features and grammatical constructions that linguists believe may reflect the influence of a previous language, a substrate that shaped the way the incoming Gaelic was pronounced and structured by speakers whose native tongue was not Gaelic. This kind of substrate influence is a common phenomenon in historical linguistics. When a community shifts from one language to another, they often transfer features of their original language into the new one, creating a distinctive dialect that carries traces of what came before. The very specific phonological features of Scottish Gaelic, as spoken on Lewis or Islay or the smaller Hebridean islands, features that differ from mainland Gaelic dialects in ways that cannot be explained simply by geographic isolation, may be the linguistic legacy of the pre-Gaelic, pre-Pictish population the sounds of an ancient language that is no longer spoken anywhere, surviving in the way a later language was adapted to fit the mouths that once spoke something very different. The Norse period also left linguistic traces that are themselves informative about the pre-Norse population. In Orkney and Shetland, the local Norn language, the Norse dialect, spoken in the Northern Isles after the Norse settlement, gradually gave way to Scots English between the 15th and 18th centuries. But even in the Scots English of Orkney and Shetland, words and place name elements of Norse origin survive in large numbers alongside words of uncertain origin that may predate the Norse entirely. The Orkney dialect of Scots preserves linguistic fossils of several layers of the island's population history, Norse, Pictish, possibly earlier, all compressed into a vernacular that modern Orcadians use to talk about fishing and farming and the everyday business of island life. The linguistic persistence, like the genetic persistence, is a consequence of island geography. Languages change more slowly in geographically isolated communities because there are fewer contacts with outside populations speaking different languages, fewer marriages that bring speakers of other languages into the community, fewer economic pressures that incentivize learning the language of a dominant outside group. The islands were not perfectly isolated, as we have seen. They received significant external influences at multiple points in their history. But the isolation was real enough and sustained enough to allow the older linguistic strata to persist in ways that they did not on the mainland, where the replacement of one language by another was more thorough and more complete. The overlap between the genetic distinctiveness and the linguistic distinctiveness of the island communities is not a coincidence. Both reflect the same underlying reality of relative isolation combined with genuine external contact, the dynamic that we have seen in the genetics and that also characterizes the linguistic history. The islands were open enough to receive new populations and new languages and new cultural influences, but they were closed enough to maintain continuity with what was there before, to layer the new onto the old rather than replacing the old entirely. The result, in genetics, is the elevated ancient ancestry we have been tracing. In language, it is the preserved substrate features and the archaic vocabularies. In culture, it is the persistence of traditions and practices that predate the dominant Celtic and Norse identities that officially characterize these communities. All three dimensions, the biological, the linguistic, the cultural, reflect the same population history, seen through different lenses. At this point in the investigation, a reasonable question is whether any of this actually matters in the present. The people of the Scottish Islands are modern British people. They have the same legal rights and the same participation in contemporary society as anyone else in Britain. The fact that their Y chromosomes carry haplogroups that are older than the Bronze Age migrations, or that their mitochondrial DNA connects them to ancient Atlantic Neolithic communities, or that their faces sometimes carry phenotypic traits that reflect ancient hunter-gatherer ancestry, does not give them any special status in contemporary society that they would not otherwise have. So, does the deep history matter? The answer depends on what you think history is for. If history is just an account of events that we study to know what happened before now, then the deep genetic history of the Scottish Islands matters to the extent that any history matters, which is to say, considerably, because knowing where you come from and how your community got to be the way it is belongs to the basic human need to understand yourself in the context of something larger than your own individual life. But if history is also a corrective, a way of pushing back against false narratives that have caused harm and that continue to shape how people understand themselves and others, then the deep genetic history of the Scottish island communities matters particularly because it challenges one of the most persistent false narratives in British history. The narrative that the Celtic peoples are the foundational population of Britain and Ireland, the original stock on which later Viking and Norman and English influences were layered. This is not a completely false narrative. The Celtic cultural influence on Britain is real and deep and important, but it is false insofar as it treats the Celts as if they were the original inhabitants of these islands rather than themselves, a relatively recent layer in geological terms, laid over a much older substrate that the Celts themselves modified and built on and incorporated into their own cultural traditions. The real foundational population of the Scottish Islands is not Celtic. It is Atlantic Neolithic and WHG, and whatever else was here before the Celts arrived, and has persisted, in diluted but measurable form, in the genetics and the languages and the traditions of the people who live here today. Understanding this does not diminish the Celtic contribution. It puts it in proper perspective, as one major episode in a much longer story rather than the first episode, and the one that most defines what these communities are and where they come from. The false foundational narrative also affects how the island communities have historically been understood by outside observers, whether those observers were Roman administrators who drew a line at Hadrian's Wall and described everything north of it as barbaric, or Victorian ethnographers who categorized the Celtic and Norse populations of the islands within a racial hierarchy that had already decided which populations were superior and which were inferior, or modern journalists who write about the Scottish Islands primarily through the lens of tourism and tartanry, without engaging with the deep history that makes these communities genuinely significant beyond their scenic appeal. In all of these cases, the depth of the population history, the antiquity of the genetic and cultural substrate, has been invisible to the outside observer because the tools to see it did not exist or were not being applied, or because the frameworks being used to understand the population were too simple to accommodate what the evidence actually shows. The ancient DNA revolution has changed this. It has not changed everything, and there are still enormous gaps in our knowledge, enormous questions about the early population history of the British Islands that cannot yet be answered with the evidence available. But it has changed enough that a new and more accurate picture of the island population history is now possible, a picture that places the island communities correctly as the descendants of some of the oldest populations in the British Isles, as the guardians of genetic and cultural traditions that extend back to the Mesolithic and the early Neolithic, and that connect them to a wider Atlantic world whose full extent we are only beginning to appreciate. The picture that emerges from this evidence is not simpler than the old picture of Celtic and Norse islanders. It is more complex, but it is also more interesting and more true and more respectful of the actual depth and richness of the history that these communities carry in their cells and in their stories, and in the way they stand on their island, cliff tops, looking out at the same ocean their ancestors have been watching for 12,000 years. The Atlantic is not a barrier. It never has been. For most of human history in the regions we have been discussing, the Atlantic was a road. It was the main route of communication and exchange along the western edge of Europe, connecting communities from the warm coasts of southern Iberia to the cold subarctic shores of the Northern Isles in a network that was active and vital for thousands of years before the Indo-European languages arrived and eyes changed the linguistic map, and thousands of years more before the Norse and Norman conquests changed the political map. The genetic legacy of the people who traveled that road, who were born on those islands, and who sailed those routes, and who built their stone monuments in alignment with the movements of a sun and moon that they watched with a precision we are only beginning to reconstruct, is still present in the DNA of the people who live on those islands today. It is visible in their faces. It is measurable across haplogroups. It is traceable in the ancient DNA samples taken from their ancestors' bones. And it is, in every sense that matters, still alive. This is what it means that islanders look different. Not just that they carry physical traits that reflect an ancient and genetically distinctive ancestry, but that they are, in a biological and historical sense, living documents of the Atlantic world, embodied archives of a population history that extends back further than any other currently surviving evidence of continuous human habitation in the British Isles. The faces that outside observers have found striking and anomalous and hard to categorize within the usual frameworks of European phenotypic variation are the faces of that history. They are the product of everything we have traced in this investigation: the WHG ancestry, the Atlantic Neolithic ancestry, the Pictish layer, the Norse overlay, the Gaelic reinforcement of the ancient Atlantic substrate, all of it compressed into the specific features of specific individuals standing on specific islands, looking out at the Atlantic that their ancestors have known for longer than most of the genetic and cultural layers that now overlay their deepest heritage. The depth of that heritage is both humbling and exhilarating to contemplate. Humbling because it reminds us how provisional and recent the identities we take most seriously actually are, how much of what we think of as fundamental to who we are turns out to be a relatively recent overlay on something much older and much more complex. Exhilarating because it reveals that the human past is not the simple story we were taught, not a linear progression from primitive to complex, from local to connected, from darkness to the light of written history, but something far stranger and richer and more deeply interconnected, a web of human movement and exchange, an ancestry that has been reshaping the populations of the Atlantic world since the ice retreated, and the first people looked out at the ocean and decided to see what was on the other side. The story of why Scottish islanders look different is, in the end, the story of the Atlantic world, told through the specific and particular and irreplaceable lens of the people who have lived on its northernmost islands for the longest time. It is a story about survival, about persistence, about the way geography protects the past and allows it to be carried forward into futures that its original bearers could not have imagined. And it is a story that is still being written, still being uncovered, still yielding new evidence to the researchers who are willing to look deeply enough into the ancient DNA and the ancient monuments and the ancient traditions to see what is actually there beneath the Norse overlay and the Celtic layer and the British political identity and all the other things that have been added to the surface of this history since its deep foundations were laid in the Mesolithic and the Neolithic on the Rhine. Atlantic edge of the world, the face in the photograph, the man in the Outer Hebrides, with the wind off the Atlantic pulling at his jacket and the dark eyes and the olive skin that seem paradoxical at this latitude. He is not a paradox. He is a document. He is the living record of 12,000 years of population history, compressed into a face that a camera caught on a grey Atlantic afternoon. He does not need to know the haplogroup frequencies, or the WHG ancestry percentages, or the ancient DNA comparisons with Neolithic burial populations to be what he is. He is what he is, regardless of whether anyone ever analyzes his genome. The history is already there, already written in him, already expressed in the specific combination of features that makes him recognizable to researchers who know what they are seeing. The science is just the language that finally allows us to read what was always already present, always already visible to those willing to look beyond the simplest explanations for the most complex realities. And the islands endure. The stones at Callanish still stand in their 5,000-year arrangement, still aligned to the southernmost moonrise, still marking on the landscape the cosmological understanding of people who have no name in any written historical tradition, who left no text and no inscription beyond the arrangement of the stones themselves and the bones they placed in the earth beneath them. Skara Brae still sits on the Orkney Bay, where it was buried by sand 4,000 years ago, and uncovered by a storm in 1850, its stone furniture still in place, its stone hearths still readable as the centers of domestic life in a community that was sophisticated and connected and aware of the wider Atlantic world long before the idea of Britain as a political or cultural entity existed. Maeshowe still aligns to the midwinter sun, and every year, when the days are shortest and the Atlantic weather most brutal and the sky closes down to a narrow slot of grey light between storm clouds, the sun still finds its way through the entrance passage and illuminates the back wall of the chamber, as it was designed to do, as it has done every winter for 5,000 years, as it will continue to do long after every living person who understands why it happens has been returned to the earth and become themselves a part of the record that future researchers will try to read. The islands endure, the stones endure, and the people, carrying their ancient genetics and their deep traditions and their faces that the Atlantic wind has shaped over more generations than anyone can count, endure too. Now we need to go into a dimension of this story that has barely been touched in any popular account of the Scottish island peoples, and that is the question of what the most recent ancient DNA research, the work that has been published in the last 5 to 7 years, using techniques that were not available before, has actually revealed about the specific population history of specific island communities. Because the picture we have been developing in broad strokes, the WHG ancestry, the Atlantic Neolithic, the Bronze Age steppe modifications, the Pictish layer, the Norse arrival, it is a picture built from general principles and representative studies. When you get into the specific island by island, community by community analysis that the most recent research is beginning to provide, the picture becomes both more detailed and more surprising. Orkney has been the most intensively studied of the Scottish island groups, partly because it is the most accessible to mainland-based researchers, and partly because the sheer density of Neolithic and Bronze Age archaeological sites on the islands provides a rich archive of ancient DNA. The studies that have been published from Orkney ancient DNA research have consistently shown a pattern that illustrates the general principles we have been discussing, but with a level of precision that allows specific conclusions. The Neolithic Orcadian population, as recovered from passage tomb burials at sites including Isbister on South Ronaldsay and Quantinus on the mainland, shows a genetic profile that is distinct from the population that appears in the archaeological record in the subsequent Bronze Age. The Neolithic Orcadians were primarily descended from the Atlantic Neolithic farming expansion with significant WHG admixture, and they show the close genetic affinity with Irish Neolithic populations and Breton Neolithic populations that we discussed earlier. The Bronze Age Orcadian population shows the modification expected from the steppe-derived migrations, with incoming R1b lineages and shifts in autosomal ancestry, consistent with the broader Bronze Age transformation. But the modification is, in the Orkney data, measurably less complete than in comparable data from southern Britain. The ancient ancestry signal is stronger in Bronze Age Orkney than in Bronze Age Wiltshire or Bronze Age Yorkshire, as researchers would expect given the geographic isolation of the Northern Isles from the primary migration routes. The Iron Age and Pictish period data from Orkney is sparser, because the transition to cremation as a burial practice in some Iron Age communities makes ancient DNA recovery harder, and because the Pictish period sites have been less systematically excavated for ancient DNA than the Neolithic sites. But the preliminary data that does exist suggests, tentatively and subject to revision as more samples are analysed, that the Iron Age and early Pictish population of Orkney showed again a somewhat higher than expected retention of the ancient Atlantic ancestry compared to Iron Age populations in southern Britain. By the time the Norse arrived in the 9th century CE, the existing Orcadian population had its own distinctive genetic profile, one that was itself the product of thousands of years of accumulation and modification, and the Norse intermarriage with that population created the specific genetic mosaic that characterizes modern Orcadians. Shetland tells a somewhat different story because it received more intensive Norse settlement than Orkney relative to the size of the pre-existing population. The Norse presence in Shetland was numerically dominant in a way that it was not in Orkney, and the modern Shetlandic population shows correspondingly higher Norse ancestry percentages. But even in Shetland, the pre-Norse substrate is detectable. The ancient Atlantic ancestry is there in diminished but measurable proportion, and the oldest haplogroup signals persist at frequencies that reflect the layered history of the islands, rather than a simple Norse takeover of a previously uninhabited territory. The Outer Hebrides present the most interesting case from the perspective of ancient ancestry preservation because the combination of their geographic position, their late and partial incorporation into mainland Scottish political and economic structures, and their deep Gaelic cultural identity created conditions for the ancient genetic substrate to persist at particularly elevated frequencies. Studies comparing the modern genetic profiles of Outer Hebrides populations with those from mainland Scotland and from Ireland consistently find that the Hebridean populations show the highest proportions of Atlantic, Neolithic, and WHG ancestry among the comparison groups, with the Norse ancestry contribution present but relatively modest compared to the Northern Isles. This makes the Outer Hebrides, in genetic terms, the most direct living representatives of the Atlantic, Neolithic, and WHG populations that we have been discussing throughout this investigation. The people of Lewis and Harris and North Uist and South Uist and Barra are, in measurable and documented ways, more directly descended from the people who built the Callanish stones than almost anyone else on Earth. They carry a genetic connection to the megalith builders that has survived the Bronze Age steppe migrations and the Norse settlement and the later mainland Scottish incorporation precisely because the islands were far enough from the main migration routes to resist the complete erasure of the older populations. The specific features of the Hebridean phenotype, the ones that outside observers have been noting and puzzling over for centuries, including the relatively darker skin tones and the heavier facial architecture that appears with higher frequency here than in mainland Scottish or lowland English populations, reflect this elevated ancient ancestry in exactly the way that population genetic theory would predict. The WHG populations had darker pigmentation than the subsequent incoming populations. The Atlantic Neolithic populations, though lighter than the WHG populations, retained some of that darker pigmentation characteristic because they had mixed significantly with the WHG populations during their migration along the Atlantic coast. The Bronze Age steppe populations brought lighter pigmentation genes, as the selection sweep toward lighter skin that occurred in the Holocene. European population was well advanced in these incoming groups. In the Outer Hebrides, where the Bronze Age steppe contribution was proportionally smaller than elsewhere, and where the ancient Atlantic ancestry was larger, the darker pigmentation genes are present at frequencies that produce, in a notable proportion of the population, the phenotypic traits that distinguish the Hebridean population from the mainland population, where the Bronze Age steppe genes are more thoroughly mixed in and the ancient darker pigmentation genes are diluted to lower frequencies. This is not a description of a racial type. It is a description of how specific genetic variants, with measurable effects on specific phenotypic traits, are distributed at different frequencies in different populations because those populations have different histories. The same genes are present everywhere in Britain. They are just present at different frequencies in different places because different migration events reach different places at different times and in different proportions. The Outer Hebrides retained more of the old frequencies because the islands retained more of the old populations. The faces that result from those retained frequencies are the faces of the ancient Atlantic world, expressed in the features of people standing in Stornoway on a rainy Wednesday morning or fishing off the rocks on Barra in the late afternoon light. Now, let us turn to a topic that has been waiting in the background of this investigation since the beginning. The Finn folk, the Selkies, the Blue Men of the Minch, the supernatural beings of the Scottish island folk tradition that are associated specifically with the sea, with the deep ocean, with the transition between human and non-human, and that appear in the folklore of the Orkney and Shetland and Hebridean island communities, in forms that are distinct from the fairy and supernatural traditions of mainland Scotland and Ireland. These beings are not simply local variations on a universal European folk tradition of sea spirits. They have specific characteristics that suggest, at least to some researchers who study the folklore alongside the archaeology and the genetics, that they may preserve cultural memories of real historical encounters between different human populations on the North Atlantic. The Finn folk of Orkney and Shetland are described in the folklore as a race of people who live underwater, in a kingdom called Finn Folcahim beneath the sea, but who come to land periodically, particularly to take human partners. They are physically beautiful, dark, sometimes described as having olive or darker skin, and they possess supernatural abilities, including shape-shifting and the power to compel. The Selkies, the seal people of the same tradition, are similar but more specifically associated with seals, with the ability to shed a seal skin and take human form, and with a melancholic quality, a longing for the sea that makes their time on land always temporary, and their relationships with humans always ultimately tragic. The Blue Men of the Minch are sea spirits associated specifically with the strait between Lewis and the Scottish mainland. Dangerous creatures who challenge ships and their captains to verbal contests, and who have a distinctly humanoid form but clearly belong to a different category of being from ordinary humans. One interpretation of these traditions is purely symbolic. The sea spirits represent the danger and the mystery of the ocean, externalized as supernatural beings, because that is how pre-modern cultures processed the experience of living on the edge of an unpredictable and sometimes lethal natural force. This is a reasonable interpretation, and probably contains truth. But another interpretation, one that some folklorists and some archaeologists have found worth considering, is that these traditions preserve distorted memories of encounters with actual human populations who were genuinely other, who seem different enough from the local population to be experienced as supernatural or at least as incomprehensibly strange. If the Neolithic and Bronze Age Atlantic island communities were interacting with populations of genuinely different physical appearance and cultural practice, whether those populations were the earlier WHG hunter-gatherers encountered by the arriving Neolithic farmers, or later arrivals from directions that the established islanders had not experienced before, then the supernatural other of the folk tradition might be, at its deepest layer, a cultural memory of that genuine encounter with human difference. This is a speculative interpretation and needs to be held as such. But the specificity of the Scottish Island seafolk traditions, the way they consistently describe beings who are physically distinguishable from the human community, who are associated with the sea and with dark beauty, and with a quality of otherness that is dangerous but also compelling, fits oddly well with what we know about the population history of these islands. The earliest populations, the WHG peoples, would have looked different from the Neolithic farmers who arrived by sea and began establishing communities on the islands. The Neolithic farmers, or at least their descendants, would have perceived the residual hunter-gatherer communities that persisted in isolated areas as genuinely other. The Norse, arriving into communities that looked and lived and spoke differently from themselves, would have registered the existing islanders as strange in ways that might, over generations of storytelling and mythological elaboration, crystallize into the specific form of the seafolk tradition. None of this proves anything, but it adds a dimension to the story that the genetics alone cannot provide. The dimension of how people experienced and encoded in cultural memory the experience of encountering genuine human difference across the millennia of the island's population history. We are reaching the place in this investigation where we need to draw threads together and allow the full picture to emerge from all of the specific evidence we have been examining. The picture is this. The Scottish Islands and the other Atlantic island and fringe communities of Britain and Ireland are distinctive. They are genetically distinctive in ways that reflect a population history extending back to the earliest post-glacial inhabitants of these islands. They are linguistically distinctive in ways that reflect the layering of multiple language strata with traces of pre-Indo-European and pre-Celtic substrates still visible to careful analysis. They are culturally distinctive in ways that reflect both the deep antiquity of the traditions they carry and the specific history of contacts and modifications that have shaped those traditions over thousands of years. And they are phenotypically distinctive in ways that are the direct biological expression of the genetic distinctiveness, the visible face of a population history that most people have been taught to understand in terms far too shallow to accommodate the actual depth of what is there. The reason for the distinctiveness is not mystery in the supernatural sense. It is not the result of intervention by beings from outside the normal human world, though the folk traditions have encoded the experience of that distinctiveness in supernatural terms that carry their own kind of truth about the human experience of encountering genuine difference. The reason is history. Deep history. The kind of history that extends back to the Mesolithic period, to the first people who walked onto these islands as the ice retreated and the land rebounded and the forests began to establish themselves on the hillsides, and who built their lives here, and had children here, and died here, and whose descendants are still here, still carrying in their DNA the evidence of their ancestors' presence, still shaped in some of their features by the same gene variants that their remote ancestors carried, still standing on the same Atlantic edge, looking out at the same ocean that their ancestors have been watching for 12,000 years. This is what it means to be an islander in the deepest sense, not just to live on an island, not just to identify with an island community, but to be the descendant of a population that has been on that island long enough that the island has shaped you, not just culturally but biologically, that the specific history of that island has left its mark in your cells and in your face, and in the way you relate to the landscape around you. The Scottish Islanders and the other Atlantic island peoples of Britain and Ireland are this in a way that almost no other modern European population can claim so completely. They are the product of their own islands in the deepest possible sense. They are the living evidence of their island's population history. And when they look different from the mainland populations, when their faces carry traits that make outside observers pause and puzzle and reach for explanations that the usual frameworks of British identity cannot easily supply, what they are seeing is that history expressing itself. The ancient Atlantic world, the connected maritime civilization of the Neolithic, the hunter-gatherers who preceded it, the Bronze Age modifications, and the Iron Age Pictish culture, and the Norse overlay and the Gaelic reinforcement, all of it compressed into a face, a set of features, a genetic profile that carries within it, readable now by modern science, the deepest record of continuous human presence in the British Isles. That is the real reason islanders look different from every other European, not genetics alone, not history alone. But the specific interaction between geography and history and genetics that island life produces, the way isolation and connection combine in island communities to create something that preserves the past while also engaging with the present, that carries the deep genetic inheritance of the Atlantic world, while also living in the contemporary world of Stornoway and Kirkwall and Lerwick and Douglas. The islands are archives. Their peoples are the living contents of those archives. And the distinctive faces that first drew our attention at the beginning of this investigation are the covers of books that contain, inside them, one of the deepest and most consequential stories in all of European population history. The story is not over. The research continues. New ancient DNA samples are being analyzed from new sites across the island archaeology. New techniques are being developed that will allow finer resolution of the genetic connections between specific island communities and specific ancient populations. The picture will continue to change, continue to become more detailed and more nuanced, continue to surprise researchers with connections they had not anticipated and with evidence for events that have left no trace in any written record. The deep history of the Scottish Islands is not a finished story. It is an ongoing investigation, one of the most interesting ongoing investigations in all of human prehistory, and the people who are its living subjects, who carry the genetic record in their cells and the cultural memory in their traditions, are participants in that investigation in ways that commercial genetic genealogy tests are only beginning to make accessible to individual families. What we can say with confidence now, at this point in the investigation, is that the old simple picture, the picture of Celtic and Norse islanders with a bit of Viking heritage thrown in, is not wrong exactly, but it is radically incomplete. It captures the last 2,000 or 3,000 years of a population history that extends back 12,000 years. It describes the top 2 or 3 layers of a stratigraphy that has at least 7 or 8 distinct layers. It tells you about the face of the house, but not about the foundations. And in the case of the Scottish island communities, the foundations are arguably the most interesting part of the structure. They are the part that connects these communities to the earliest inhabitation of the British Isles. They are the part that links them to the Atlantic megalithic world, and through that world to the wider Atlantic connections that may extend even across the ocean. They are the part that explains why the faces look the way they do, why the genetics read the way they do, why the folk traditions carry the specific content they carry. They are the oldest part. And in the islands, the oldest part survived. When researchers first encounter the unexpected depth of the genetic data from the Scottish Islands, when they see the elevated WHG ancestry percentages and the ancient haplogroup frequencies and the Atlantic Neolithic signals, they often use a specific phrase to describe what they are seeing. They say the islands preserved something. This is exactly right, and it is the key to everything we have been examining. The islands preserved something that the mainland lost, or lost more thoroughly, because the islands were harder to reach, because the sea protected their populations from the full force of successive migration waves, because geography allowed the ancient to persist alongside the new, rather than being replaced by it. The islanders look different from every other European because they are, in the deepest and most literal sense possible, carrying something old, something that the rest of Europe has largely diluted away. Something that the ancient DNA researchers can now measure and document and trace back to its origins in the Mesolithic and the Neolithic and the long Atlantic prehistory of the British Isles. That something is alive in every person who carries it. It is alive in the woman from Lewis who has never had her genome sequenced and has never heard of Western hunter-gatherers, but who knows that her family has been on this island for as long as anyone can remember, and who sees in her own face and her children's faces a resemblance to the faces in old photographs of people who were themselves old when the photographs were taken. It is alive in the man from Orkney who has heard the stories his grandparents told about the families who have been farming the same land since before anyone thought to write down when they arrived. It is alive in the folk traditions and the music and the language and the material culture and all the other ways in which communities preserve their deepest selves across the generations, often without knowing exactly what it is they are preserving, knowing only that it matters, that it connects them to something real and important and irreplaceable, that it is theirs in a way that is not primarily legal or political, but biological and historical, and in some sense beyond either of those categories. The stones at Callanish stand in the wind off the Atlantic, 5,000 years old, still aligned to the southernmost moonrise. The people of the Outer Hebrides live their lives around them, familiar with them in the way you can only be familiar with something that has been part of your landscape since before memory. The genetic connection between those people and the people who built those stones is real, documented, measurable. The stones are one kind of monument, the people are another kind of monument. Both are expressions of the same deep Atlantic history. Both endure. We have been moving in this investigation, from the general to the specific, and back to the general, from the broad picture of Atlantic European population genetics to the specific island communities and the specific evidence from those communities, and back to the broader meaning of what the evidence shows. Now we need to move in a different direction. We need to look at the edges of what is currently known, the places where the evidence is incomplete or contested, or points toward conclusions that mainstream research has not yet fully incorporated, because some of the most interesting aspects of the Scottish island story live in those edges. The first edge is the question of what the pre-WHG population of Britain was, if there was one. The Western hunter-gatherers, whose genetic signature we have been tracking as the oldest detectable layer in the Atlantic island, populations were themselves newcomers to Britain in a geological sense. They arrived after the last glacial maximum, following the retreat of the ice. But before the last glacial maximum, before Britain was covered by ice, there were people here too. The archaeological record shows human presence in Britain extending back hundreds of thousands of years, interrupted by periods of cold and glaciation, and then renewed as warmer interglacials allowed recolonization from continental refugia. These earlier inhabitants of Britain were not anatomically modern humans, they were archaic human populations, predecessors and relatives of both Neanderthals and modern humans, living on the landscape that would become Britain in periods before the last ice age buried it. The genetic contribution of these earlier populations to the modern British population is a matter of active research and considerable uncertainty. The general assumption has been that the last glacial maximum was a sufficiently thorough demographic reset that whatever populations inhabited Britain before it were effectively eliminated, with the modern British gene pool reflecting only the post-glacial recolonization from the Iberian and southwestern French refugia. But this assumption is being questioned as the tools for detecting ancient genetic contributions become more sensitive and as researchers accumulate more data about the specific ways in which archaic human populations contributed to the existing modern human gene pool. We know that modern humans interbred with Neanderthals. We know that Neanderthal DNA is present in all modern non-African humans at a low percentage. We know that Neanderthals were present in Britain before the last glacial maximum. The question is whether any Neanderthal genetic contribution to the modern human populations who recolonized Britain after the glaciation is disproportionately present in the populations that came from the Iberian refugia, since those refugia were the places where the earliest modern human populations in Western Europe would have had the most time and opportunity to mix with the Neanderthal populations of the region. This is not a question that the current ancient DNA literature on British island populations has addressed directly, because the Neanderthal contribution to modern humans is so small and so evenly distributed across non-African populations as a whole, that detecting differential Neanderthal ancestry in specific modern European populations is at the current limit of what the analysis tools can resolve. But it is a question that future research may be able to address, and if it turns out that the Atlantic fringe populations carry slightly elevated Neanderthal ancestry as a consequence of descending from the Iberian refugial populations that had the most ancient contact with Neanderthals, then the story of why islanders look different would have yet another layer added to it. The Neanderthal contribution to the Atlantic islander phenotype, if it exists at all, would be vanishingly small, below any threshold that would be detectable in individual appearance. But its presence at a population level would add yet another chapter to the already extraordinarily deep genealogy we have been tracing. The second edge is the question of the Cheddar Man and what he represents. In 1903, the skeleton of a man was excavated from Gough's Cave in Cheddar Gorge in Somerset and subsequently dated to approximately 9000 BCE, making him one of the oldest complete skeletons of an anatomically modern human found in Britain. Cheddar Man, as he became known, was a Western hunter-gatherer of the type we have been discussing throughout this investigation. In 2018, Ancient DNA analysis of Cheddar Man's remains revealed something that attracted enormous public attention and considerable political controversy. The analysis predicted, using genetic markers associated with pigmentation traits, that Cheddar Man likely had dark skin, dark curly hair, and blue eyes. The combination of dark skin and blue eyes was counterintuitive to many people's expectations of what the earliest British people looked like, and the revelation generated a polarized response. Some people found it fascinating and perfectly consistent with what population genetics had already established about WHG pigmentation. Others found it politically motivated or scientifically dubious. The science is straightforward, though the pigmentation prediction for ancient individuals is not a simple matter. The specific genetic variants associated with dark skin pigmentation in modern populations were present in Cheddar Man's genome, while variants associated with lighter skin were largely absent. The blue eyes prediction came from the presence of genetic variants strongly associated with light eye color in modern European populations. The combination is genuinely common in WHG individuals, who as a group showed higher frequencies of light eye color than modern Europeans, while also showing higher frequencies of darker skin pigmentation, a combination that, in modern populations, would be unusual, because the selection sweep toward lighter skin that occurred in the European Holocene has brought the two traits into closer correlation, but that, in the pre-Neolithic period, was not paradoxical at all. The WHG populations had been at European latitudes for long enough to accumulate some selection for lighter eyes, possibly because light eyes involve less melanin and are therefore more sensitive to low-light conditions, and might have been advantageous in specific ways in the hunting and gathering context, but had not been at European latitudes long enough for the thoroughgoing selection toward lighter skin that the subsequent 10,000 years of European population history would produce. Cheddar Man matters for the Scottish Island story because he represents, in specific and dramatic form, what the WHG ancestry that the island populations carry actually looks like when it is not modified by the lighter skin genetics that the Neolithic farming expansion and the Bronze Age steppe migrations brought in. The elevated WHG ancestry of the Outer Hebrides population does not mean that the Hebridean people look like Cheddar Man. They do not, because their WHG ancestry is mixed with three other major genetic streams, each of which contributed its own phenotypic effects to the mix. But it means that the phenotypic consequences of that WHG ancestry, the slightly darker skin tones, the heavier facial architecture, the specific eye color distributions that appear more frequently in the island populations than in mainland populations, are the diluted but still measurable expression of the same genes that gave Cheddar Man his specific combination of physical traits. He is the end member of the distribution, the case where the WHG ancestry is present at 100% and none of the modifying later ancestries are present at all. The island populations are somewhere in the middle of the distribution, carrying the WHG contribution at elevated but not pure proportions, showing its phenotypic effects at lower intensity but in patterns that are still statistically distinguishable from the populations where the WHG contribution is more thoroughly diluted. The Cheddar Man controversy illustrated something important about how people receive population genetic information when it challenges pre-existing beliefs about identity. Many of the people who rejected or dismissed the Cheddar Man findings did so not because they had specific scientific objections to the methodology, but because the findings did not fit their prior beliefs about what British prehistory looked like and who belongs in it. The findings were and are politically inconvenient for people who want to use prehistoric British identity as a foundation for contemporary exclusionary claims about who is and is not genuinely British, because those claims typically rely on a picture of ancient Britons as fair-skinned European people who look like the current majority population of Britain. The genetic evidence directly contradicts this picture. The earliest inhabitants of Britain, the people who have the strongest claim in any ancestry-based argument to being the foundational British population, were people who would not fit the physical phenotype that exclusionary nationalist discourse uses to define Britishness. This is not an argument for any specific contemporary political position. It is simply an observation that the genetic evidence does not support the use of ancient ancestry as a justification for modern ethnic exclusion, because the ancient ancestry of Britain is more diverse, in terms of the phenotypic traits it expressed, than any such argument acknowledges. For the Scottish island communities, specifically, the Cheddarman story is a reminder that the ancient ancestry they carry in elevated proportions connects them to a human past that does not fit neatly into the conventional frameworks of European identity politics. Their deepest roots are in a population that predates the Celts, predates the Bronze Age steppe migrants, predates farming, and that expressed physical traits that would now be classified as ethnically diverse rather than specifically Northern European. The islanders are, in their deep genetic heritage, connected to the full breadth of the Atlantic world, from the dark-skinned, blue-eyed hunter-gatherers of the Mesolithic to the coastal farming communities of the Neolithic Atlantic to the Norse settlers of the Viking Age. They are a synthesis. They are the product of 12,000 years of layered human history on the edge of the Atlantic. And the idea that their identity can be captured in any simple ethnic or cultural category is contradicted by everything the evidence shows about the complexity and depth of that history. The third edge that deserves attention is the question of what happened to the populations that did not survive, the genetic lineages that have been lost to the record because the communities that carried them did not persist into the modern period in recognizable form. Population genetics can sometimes detect the presence of lost populations through what are called ghost populations, ancient genetic signals in modern populations that do not match any known ancient DNA sample and that must therefore reflect ancestry from a population that has not yet been sampled or that left no direct descendants identifiable by their ancient DNA. Ghost population signals have been found in various parts of the world, including in European ancient DNA data, where they sometimes suggest the presence of populations that inhabited specific regions before the currently best documented populations arrived. In the context of the Scottish Islands, the possibility of ghost population contributions, ancient genetic inputs from populations that are not represented in the current ancient DNA database, is particularly interesting in connection with the pre-Neolithic and early Neolithic period. The archaeological record of the Mesolithic in Scotland, the period between the arrival of the first post-glacial inhabitants and the beginning of farming, is sparse by the standards of the later periods, but it exists, and it shows the presence of hunter-gatherer communities across the Scottish landscape, including on the islands. The ancient DNA from these early communities is extremely limited because the number of Mesolithic skeletal remains in Britain is small and the DNA preservation in many of them is poor. But the populations that inhabited the islands in the Mesolithic period, before the Neolithic arrived, may have had a genetic composition that was not identical to the WHG populations that show up in the ancient DNA literature from slightly later periods in Britain and continental Europe. If there were regional variants of the WHG genetic profile in the British Mesolithic, variants that show up in the modern population but not yet in the ancient DNA database, then the elevated ancient ancestry of the island populations might reflect not just the well-documented WHG and Atlantic Neolithic signals, but also some contribution from these as-yet uncharacterized early inhabitants. This is speculative, as ghost population hypotheses necessarily are before they are confirmed by specific ancient DNA evidence. But it is the kind of speculation that is grounded in known principles of how populations work and known gaps in the current evidence base. The Scottish Mesolithic is one of the least studied periods in British prehistory, partly because the evidence is sparse and partly because the dramatic monuments of the Neolithic have attracted more research attention. As ancient DNA research extends further back in time, and as more Mesolithic sites in Scotland are identified and excavated, the picture of who was here before the farmers arrived will become clearer. And that clearer picture may add yet another dimension to the already complex genetic history of the island communities. For now, what we have is already enough to overturn the simple story and replace it with something worthy of the actual depth and complexity of the human past in these specific places. The Scottish Islands are not simply interesting tourist destinations with attractive scenery and distinctive cultural heritage. They are among the most significant sites for understanding the deep population history of Europe and the Atlantic world. The people who live there are not simply an interesting regional subpopulation of the British population with a picturesque accent and strong local traditions. They are the living representatives of one of the oldest continuously inhabited communities in the British Isles, the bearers of genetic signatures that connect them to the pre-Neolithic past of Western Europe. the guardians of traditions whose roots extend further back in time than any written historical record in Britain goes. When you understand the depth of what is actually there, when you have followed the evidence back through the Bronze Age and the Neolithic and the Mesolithic to the first people who walked onto these islands after the ice, you realize that the right word for what the Scottish Islands represent is not just distinctive, the right word is irreplaceable. The specific genetic and cultural and historical combination that these communities embody is not something that can be reconstructed anywhere else. It is the product of this specific geography, this specific climate, this specific sequence of human arrivals and departures and interactions over 12,000 years. It is the product of the Atlantic world and of the specific position that these islands occupy in it, far enough from the main migration routes to be protected, close enough to the sea routes to be connected, old enough to have accumulated layers of human history that extend back to the very beginning of the post-glacial world in Britain. This is what the scientists are measuring when they analyze ancient DNA from Orcadian Neolithic burial sites. This is what the linguists are recovering when they trace the substrate features in island Gaelic dialects. This is what the archaeologists are excavating when they dig at Skara Brae and Maeshowe and Callanish and the Nap of Hower. And this is what the people who live on these islands carry with them, in their cells and in their stories and in their faces, every day, without needing to know the technical vocabulary or the research literature or the specific findings of the studies that document it. The history is in them. It has always been in them. The science is just the most recent and most precise tool that humanity has developed for reading what was always already there. And as we move toward the close of this investigation, as we draw together the threads we have been following and allow the full picture to resolve itself from the specific evidence and the broader patterns and the edges where the evidence is incomplete and the questions are still open, the thing that remains most striking, most moving, most genuinely astonishing about the Scottish Island story is its continuity, not its discontinuities, though those are real and documented and important, but its continuity. The way that something persists across 12,000 years of change and disruption and replacement and mixing and modification, the way that the oldest layers of the genetic profile are still there, still detectable, still expressed in the faces and the haplogroups of people who are living modern lives in the 21st century, the way that the stone circles still stand and are still known and still visited and still matter to the communities that live around them, the way that the traditions, however modified and overlaid and transformed by subsequent history, still carry within them traces of something much older than the traditions themselves. Continuity like this is rare in human history. It requires specific conditions, geographic protection, demographic stability, cultural investment in the preservation of tradition, and a degree of connection between the living community and the physical landscape it inhabits that is increasingly rare in a world of urbanization and mobility and globalization. The Scottish Islands have maintained these conditions, imperfectly and with many disruptions and difficulties, for a very long time. The highland clearances of the 18th and 19th centuries, which drove significant numbers of people from the islands and the Scottish Highlands to make room for sheep farming, were a demographic catastrophe that removed substantial portions of the island population and disrupted the cultural continuity that had sustained these communities for millennia. The impact of the clearances on the genetic and cultural record of the island communities is a real and painful aspect of the history that needs to be acknowledged alongside the deep continuity story. The people who were cleared, who were forced onto emigrant ships to Nova Scotia and New Zealand and Australia and the urban slums of the Scottish industrial cities, took their genetics and their languages and their traditions with them, dispersing the Atlantic world heritage into a global diaspora that now carries fragments of the island tradition across the world. But enough remained. The communities were disrupted, diminished, damaged. But they survived. The Gaelic language survived in the Outer Hebrides, barely, sustained by communities that maintained it through the decades when the educational system and the economic system and the social prestige system all favoured English. The crofting system survived, reformed, and protected by legislation that recognised the injustice of the clearances era. The music and the storytelling traditions survived, and the people survived, enough of them, on the islands that had been their home for 12,000 years, to maintain the continuity that makes those islands what they are. The communities that survive today on the Scottish Islands are smaller than they were at many previous points in their history. The population pressures of the modern world, the attraction of economic opportunities and services available on the mainland that the islands cannot provide, the challenge of maintaining viable communities with aging populations and outmigration of young people, these are real and ongoing problems that the island communities are grappling with varying degrees of success and varying degrees of support from the wider Scottish and British political and economic systems. The survival of these communities is not guaranteed. It requires active investment and sustained commitment from the communities themselves and from the political systems that have responsibility for supporting them. Understanding what would be lost if these communities cease to exist as living entities is part of what makes the deep history we have been tracing in this investigation genuinely important for the present. It is not simply that the genetic diversity represented by the Scottish island populations has academic interest for population geneticists. It is that these communities are the living bearers of a cultural and historical heritage that extends back further than almost any other surviving community in the British Isles. Their languages, their traditions, their music, their specific ways of relating to the island landscape, their genealogical memories, their folk practices, all of these are irreplaceable once they are gone. The stones at Callanish will stand without the community that lives around them, but the living tradition that connects the present community to the people who built those stones, however indirect and modified that connection has become over 5,000 years, is something that exists only as long as there are people to maintain it. When the last native speaker of a language dies, the language dies. When the last person who learned the old songs from their grandparents dies without having taught them to anyone, the songs die. The stones endure. The people are fragile. This is why the deep history matters for the present. Not because it gives anyone a claim to exclusivity or superiority, not because it establishes some kind of rights based on ancient ancestry that should override contemporary political and ethical considerations, but because it establishes the depth and significance of what is at stake when communities this old, with histories this deep and this irreplaceable, are threatened with dissolution. The Scottish island communities are not just communities, they are archives. They are the living memory of the Atlantic world. And the world loses something irreplaceable every time a living archive ceases to function, every time the transmission of accumulated knowledge and tradition from one generation to the next is broken by the economic and social forces that are constantly working to dissolve the specific and the local in favor of the uniform and consensus, the global. The faces are still there. The dark eyes in the grey Atlantic light. The heavier features that outside observers have puzzled over for centuries. The phenotypic expression of 12,000 years of population history, compressed into the faces of people going about their lives on islands off the edge of Europe, fishing and farming and raising their families and telling their stories and playing their music and maintaining, in the ways that are available to them in the contemporary world, the continuity that has always been the deepest fact of their community existence. They look different from every other European because they are different from every other European, in the deepest biological and historical sense of different that the current evidence allows us to articulate. They are older. Their roots go further back. Their genetic inheritance extends to population layers that the rest of Europe has largely diluted away. And the appearance of that difference, the visible face of that depth, is the thing that first drew our attention at the beginning of this investigation. The face in the photograph. The dark eyes, the olive skin at the latitude of the North Atlantic, the heavy brow in the grey light. What we have been doing in this investigation is following that first observation back to its roots, all the way back to the Mesolithic and the Neolithic, and the Atlantic megalithic world, and the connected maritime civilization that existed before any of the names we use for European peoples or European cultures had been coined. What we found there, at the roots, is not simpler than what we started with. It is richer, deeper, stranger, more connected, and more astonishing than anything the surface of the story could suggest. The stones stand in the wind off the Atlantic. The sea moves, the light changes, and the people, carrying their ancient inheritance into an uncertain future, they endure. So let us come back now to where we started. The photograph, the face. The man in the Outer Hebrides, with the wind pulling at his jacket and the grey Atlantic sky behind him and those dark eyes looking calmly at whoever is holding the camera. We know now what we did not know when we first looked at him, or rather know more than we did, because the full story is still being written, and research is still ongoing, and the ancient DNA samples are still being analysed, and the comparisons are still being made, and the picture is still resolving itself from the evidence in today, something more detailed and more true than anything available to previous generations. We know that those dark eyes and that olive skin at this latitude are not an anomaly. They are not a paradox to be explained away by pointing to some recent individual in his ancestry who arrived from somewhere else, some southern European merchant or African sailor who stopped in the islands and left descendants. They are the expression of a population history that extends back 12,000 years to the first people who walked onto these islands after the ice retreated and who built their lives here in a landscape that was just becoming habitable, that was just beginning to fill with the trees and the animals and the coastal resources that would allow a sustained human community to develop. Those first people carried genetics that expressed themselves in darker skin and heavier facial architecture and the specific combination of traits we have been tracing throughout this investigation. Their descendants, modified by thousands of years of subsequent arrivals and mixings and modifications, still carry those traits in elevated proportions compared to the mainland populations, whose deeper ancestry was more thoroughly replaced by the lighter-skinned incoming populations of the Neolithic and the Bronze Age. The man in the photograph is the current endpoint of a 12,000-year chain. He did not need to know the full chain to be its current endpoint. He simply needed to be born on this island, of parents and grandparents and great-grandparents who were also born on this island, reaching back into the deep Atlantic past that the genetics document and the monuments embody and the folk traditions preserve in their own ways. The full answer to the question we began with, the real reason islanders look different from every other European, is not a single answer. It is a layered answer, like the population history it reflects. At the most surface level, the answer is that the genetic composition of the island populations is different from that of mainland European populations, and that genetic composition expresses itself in the specific phenotypic traits we have been examining. At a deeper level, the answer is that the genetic composition is different because the island populations preserved more of the ancient pre-Neolithic and early Neolithic European ancestry than the mainland populations, because the islands were geographically protected from the full demographic impact of the migration waves that reshaped the rest of Europe. At a deeper level still, the answer is that the pre-Neolithic and early Neolithic European ancestry that the islands preserved in elevated proportions connects to a wider Atlantic world, a connected maritime civilization that linked the Scottish Islands to Ireland and Brittany and Iberia, and possibly to populations on the other side of the North Atlantic in ways that are still being understood. And at the deepest level, the answer is that the islanders look different because the islands have allowed something very old to persist, something that the rest of Europe has largely diluted away, something that connects these communities to the deep prehistoric past of the Atlantic world in ways that are visible in their faces, measurable in their genetics, audible in their languages, tangible in their folk traditions, and monumental in the standing stones that their ancestors built on the cliff tops and the hilltops and the moorland edges of the islands that have been their home since before the pyramids were conceived. That is the answer, not simple, not reducible to a single cause or a single event or a single ancestral population, but real, documented, measurable, and more fascinating, more significant, and more connected to the deep currents of human history than the simple narratives of Celtic and Norse islanders would lead anyone to suspect. The islands hold more than anyone taught you. The faces tell more than most accounts can say. And the people who live there carry, without necessarily knowing the full depth of what they carry, one of the most ancient and most significant population histories in the whole of Europe. That man in the photograph is still standing there in the grey Atlantic light. He is still looking at the camera with those calm, dark eyes that carry 12,000 years of island history in them. He does not need to know the haplogroups, or the ancient DNA percentages, or the Atlantic Neolithic migration routes to be what he is. He is the living document. He is the most recent chapter in a story whose opening was written in the Mesolithic, whose main body was written in the Neolithic and the Bronze Age, and the Iron Age, and the medieval period, and everything that came after, and whose end has not yet been reached. The story continues with him. It will continue with his children, if he has them, and their children, and theirs, carrying forward the ancient genetic inheritance of the Atlantic world into futures that none of us can predict, but that will be shaped, in some small measure, by the deep past that these islands have preserved and that these people embody. The sea moves outside the window of wherever you are listening to this, the same sea that moved outside the window of the Mesolithic hunters who were the first people to see these islands, the same sea that carried the Neolithic farmers in their boats along the Atlantic coast, from Iberia to Ireland to the Hebrides and on to Orkney, the same sea that the Norse longships crossed 1,000 years ago and that fishing boats cross today, the same sea that the haplogroup X carriers may have crossed in the deep prehistoric past, in boats we cannot reconstruct heading toward shores they could not see, following whatever combination of courage and curiosity and necessity drove them into the Atlantic dark. It is the same sea. It is the same Atlantic. It connects everything we have been discussing, and it has been connecting the communities of the Atlantic world since the first people looked at it and decided to cross it rather than be stopped by it. We are, all of us, somewhere in the story of that sea and the peoples who lived on its edges, some of us more directly than others, some of us through bloodlines that we can trace and document and that the ancient DNA research now allows us to understand with a precision that no previous generation could have accessed. Others of us through the human inheritance that connects everyone, regardless of the specific ancestry they carry, to the broad story of human migration and adaptation and survival and creativity that is the only story any of us actually belongs to. The Scottish Islanders are in that story in a specific and irreplaceable way. But the story is not theirs alone. It is the human story, told from the specific vantage point of the islands on the Atlantic edge of Europe, through the specific lens of the people who have been standing on that edge the longest. And now the light is fading in this investigation, the way light fades over the Atlantic at the end of a long day, slowly and then suddenly, with the last colour draining out of the sky and the first stars appearing over the dark water. We have been a long way in this conversation, from the Mesolithic to the present, from the individual face in the photograph to the global patterns of ancient DNA, from the specific stones at Callanish to the haplogroup X distribution in the northeastern forests of North America. We have been into the edges of what is currently known, and we have acknowledged the places where the evidence is incomplete and the questions are still open. We have tried to be honest about what is documented and what is speculative, what the evidence firmly supports and what it merely suggests. What we have found, in all of that, is a story worthy of the islands that inspired it, a story as deep as the Mesolithic and as current as the latest ancient DNA publication, a story about persistence and change, about isolation and connection, about the way geography shapes biology and the way biology expresses itself in the faces of the people who carry it. A story about the Atlantic world as a human space, a connected and dynamic and ancient human space that has been shaping the people on its edges since the ice retreated and the first communities formed on the islands and the coast. If this investigation has carried you somewhere further into the past than you expected to go tonight, and if that journey has made the present feel a little more layered, a little more connected to something deep and irreplaceable and genuine, then it has done what it was meant to do. The full story is not over. The research continues. The ancient DNA samples accumulate. The pictures becomes clearer. And the people on their islands endure, carrying their 12,000 years of Atlantic history into the future in their faces and their music and their languages and their traditions and their specific, irreplaceable way of being at home on the edge of the world. If you have been watching or listening to fall asleep, then let the Atlantic pull you under now, gently, the way the tide moves over the stones on the Hebridean beach at evening, covering them slowly and leaving the surface quiet. Everything we have discussed, the haplogroups and the migration routes and the Pictish symbols and the Callanish alignments and the faces looking out at the Atlantic from the island clifftops, let it settle into the way sediment settles on the ocean floor, quietly, over time, in layers. That is how the story was built, layer by layer, and it is still being built, still accumulating, still deepening in the genetics of the people who carry it and in the science that is slowly learning to read what has always been written there. If you found this investigation worthwhile, if the depth of this story is something you want to keep exploring, then consider subscribing so you do not miss the next journey into the deep history of the peoples of these islands and the wider Atlantic world they represent. Leave a comment if you feel moved to, and tell me where you are right now and what time it is there. What is the light doing in your part of the world tonight? Someone is always watching from somewhere unexpected, from a place on the Atlantic coast that connects them more directly than they knew to the story they have just heard, or from somewhere far inland where the Atlantic is a distant concept, but the deep past is no less present for being distant. The connection is real. The story belongs to everyone curious enough to follow it into the deep. The stones stand in the wind off the Atlantic. They have stood there for 5,000 years. They will stand for 5,000 more, at least, watching the sea and the sky and the people who move around them, who are born and who live and who die in the landscape that the stones have witnessed for longer than most human traditions can remember. In the end, the stones and the people are the same story, told in two different registers. The stone register is the most durable. The human register is the most alive. And both of them, together, are what the Atlantic Islands are, what they have always been, what they will continue to be, as long as the islands endure, and the people endure, and the sea continues to move in its ancient patterns around the edges of the world, where humans first looked out at the darkness and decided to go. Rest now. Let the Atlantic carry you. The deep past is not behind you. It is underneath you, supporting everything you are standing on, everything you will ever stand on, the ancient foundation of the human world, the islands preserved, and that the faces of the islanders still reflect, looking out at the water, patient as stone, enduring the tide.